11 minus 7 is going to give us what? 11 minus 7 is going to give us 4, right? So, so now how we now have this equation square root 2, 3, 4 all over what? 26. Then we have x, x4. Now check. Among 22, 3 go, right? So let's just say 2 go here is going to give us 13, right? And then 2 go here is 1. 2 go here is 1. Carry 1 to the side. 7. Um, so this answer can now be this what? 117, right?
Yes, sir.
Okay, so we have 117 all over 13 x 4. So this is how you can see divide, right? This one somebody
Mr.
can
Godspower, 26 can go in 2, 3, 4, 9 times.
okay 9 times. So this will now give us 9 times 9. This will now give us root 9 9x 4. So we now have 9x raised to power 4. That we can get root 9 to be 3, and then s4 is going to be s squared. So our answer is going to be 3 squared to be them. So I hope you understand how.
Is how did you get the 117? Sorry, please.
How we got the 117 is from the equation. We just divided. You can just do 2 5. You can just do 2 3 4 divided by 56. Because I was using my own head to just I said 2 going to 26 is 13, and 2
Okay,
going to
okay.
2 3 4 is just 117. You can just do the division. I don't have calculator, so I'm using my head. That's why you're seeing all of that. So
Excuse me, please. Why are we having X again? I thought we cancelled X before and Y. Why are we having X again at the end? I thought X cancelled
yeah,
X from the beginning and Y cancelled Y before we did
the
11
S,
minus 7.
please take it.
Can I answer that?
Thank you. Take a look at it. Take a look at it. Yeah, you see that S is raised to 11, and this other X at the down is raised to 7. So if we are canceling the X of the down won't finish. Eh? X will they down don't finish. The X will they up still dey. So if you check that this one gives us 1, the other one y just lost in the equation. But since x the other x is 11, cancelling the down to the up one left x raised to power 4, which was the one we were working with, x raised to power 4, this one here. And you can see we carried it alongside in every equation until it came to the square root, where square root now help to divide it down. So that's why we have an x raised to power 2. Alright. Okay, now we go over to all right, we'll solve these two. So we are done. So rationalizing denominator, the process of removing radicals from denominator of fractions is called rationalizing the denominator. I hope you understand what that means. Rationalizing. Rationalizing is just by changing the sign that is below on the denominator. That particular anyone that either plus or minus, just to change the sign. That is what is called rationalizing, or we change the sign and multiply the numerator and denominator by the new change radical expression. Now take a look at this. Say for denominator, we can this blah blah blah. Okay, now look at this very well. For a denominator with a single term, multiply by the denominator itself. So you have, for instance, if you have x is equals to b root c. So the answer is going to be s over b root c multiplied by root c and c. Oh my God. Uh, somebody's mic is disturbing us. Please, I'm seeing focus that is changing. I have to check what is up. Thank you so much. For denominator with a single term multiplied by the
Your
denominator
screen is
itself.
not placed well. I think is
Are you the only one?
I don't
Is
know,
it well
maybe
No,
the
placed
she's
now?
not too. She's
No,
not
it's
the only
upside
one. No.
down, Mr. Godspower. It's upside down. You
Wait,
can
wait,
rotate it.
rotate it.
okay.
Okay.
It's
Uh-huh.
okay now. But it's not full screen yet. It's okay now, yes.
All right. So, thank you for that feedback. So, what we are trying to say up now for denominator as sum or as difference of rational. See, I want you guys to understand something. Whenever you have a rational expression below, and then you have maybe b, let me say 2 root x. All you need to multiply the both sides with is the root x, and we not carry the 2 or the number that is beside it. That's this expression you're seeing, this particular one. Then if you have the denominator is with either plus or minus, all you need to do is change the plus or minus and multiply everything. So that of the plus and minus, see why don't detach plus and minus, you multiply everything. So what are they trying to say? Let's go over to matters. For example, one, 3 plus 5. Example two, 2 over 3 root 3 and 10. Simplest one. So please, somebody give me this particular question. Let's solve so that we can move forward. Uh, 3 root 5. Can I remember? Okay. 3 root 5, right? So we have 3, 3. Is it 3 plus root 5? Am I
Yes,
correct?
3 plus root 5.
All right. So all you have to do in this particular equation is to multiply the numerator. This is the numerator. This is the numerator. This is the denominator. So to multiply the numerator and the denominator by the conjugand, all the conjugand is the conjugand now will have 3 minus root
Mr.
5.
Godpower is 2 all over 3 plus root 5.
2 all over 3 plus root 5. Thank you. So this is the real question. Okay, now just to change this. So I was saying you have to multiply the conjugand of this now will be 3 minus root 5. This is the conjugand that you are going to use to multiply against the denominator and the numerator, or the numerator and the denominator rather. Sorry. So having said that, let's just start. uh, So this will be 3 minus root 5, and this will be what? 3 minus 5. Having said this, 3 times, let me even put it in fact, 7. So 2 times, we are doing this now. 2 times 3 is going to give us what? 6. Then minus 2 times root 5 is going to give us 2 root 5 all over the second part. 3 times 3 is going to give us what? 9. Then 3 times this, that's this against this. It's going to give us what? It's going to give us minus 3 root 5. And then root 5 times 3 is going to give us plus 3 root 5. And then root 5 is going to give us what? It's going to give us root 25. Uh-huh. And that, is going to always land us to 5. So with this now, we are going to have 6 minus 2 to 5. Then all over. Let's look at this very well. This and this can always go. So they cancel out in the equation. So we have 9 minus, and we know that square root 25 is going to give us what? It's going to give us 5. So we have 9 minus 5 at the bottom here. And with this now, we can do the simple arithmetic. 9 minus 5 is going to give us 4, right? So we have this as 6 minus 2 root 5 all over what? All over 4. So this becomes the answer. Sometimes they may put these answers like this. They can say 6 all over 4 minus 2 5 all over 4. This is 2 go here is going to give us what? 2 go there is going to give us 2 go here is going to give us 3. 2 go here is going to give us
3.
2. Then yeah, so this answer further becomes 3 all over 2 minus 2 root 5 all over what? All over 4. So sometimes they may even cancel this one here, 1, cancel this one 2. And then they leave the equation as 3 all over 2 minus um, 5 all over 2. So anyhow you see the answer, you should be able to know which one should be the answer among these. So that's that. Go over to so this other one is the same thing. You solve it same but simplest one. You say reduce this in the simplest one, just like that. I believe you understand what this. Okay, let's see whether we can solve this particular one. So write 3 all over 2 root 3 all over 10. Let's see if we can. Somebody give me that. Somebody give me that.
2 over 3, not 3/2.
2/3.
3/4.
Yeah, with 3/10.
I'm very sure it's 3/2.
I don't like when
With
I'm
three
not
over
getting the correct. The correct. This 2 over 3.
2/3.
2 over 3. Then the other one is
2/3.
just for somebody root 3 over 10. We should work together. I must not check everything. I'm asking for question. We should get the correct one together so we can work. I'm a little bit dull this evening, so uh, good. So this 2 over 3 had with 3 over 10, and this can also be written as 2 over 2 all over 3. Then we have dot root 3 and also dot root 10. I believe we've learned all this on the previous lessons. So, okay, now what do we need to do now? With this, now we can say 2, 2 root 3 will multiply, um, or let me just join it together. This will now be 2 root 3, right? And then this will also be 3 root what? 10. And now we have to look for the multiply the both side by the conjugate or the radical expression that needs to change, which is by rationalizing the both sides. And by doing that, we are going to multiply this by root 10 and root 10. So this is going to be what? Um, 2 root 2 root 3 times root
with
10. This is
30.
going to give us 2 root
30.
30 because 3 times 10 is going to give us 30. And then this other one is going to be
33
3
square.
root 10 times 10. That's 3 root 100, right?
Yes, sir.
Yeah. So with this now, we can do what we have to do. Root 30, do we know what root 30 is all about? Okay. If it doesn't go that way, we can say 2 root 3, and then we can say this is 30 all over 100. Anyhow you want to do it, still go. Or, okay, we have root 100. Square root 100 is already 10, so no need of you going to go. Let's not go into this pattern now. Let's just okay. So we say this is going to give us 2 root 30 all over 3 times what? 10, which is going to give us what? 2 root 30 all over 30. So we can say 2 here 1, 2 here 16. So this gives us root 30 all over what? 15. This becomes the answer. All right. Can we go over the next?
Sir, please hold on.
You need
So,
something?
can you go back? Yes, I'm writing it out.
Just snap it, please. You can't write here now. It's going to slow that down. Thank you.
Okay, sir.
All right. Then uh, the end root, this, that. You don't have too much time to just get the ideas. End truth, this, the end is written as a sign as this index, blah, blah, blah. Okay. Uh, all right. All this is just as simple as you know before. Let's solve this. Let's solve this. If n is root 5 and n is root b are real numbers, then this and this, that you can pick if they are of the same if they are of the same root, you can pick the same root and then you multiply the both of them itself on. We've already been doing this. Then we said if n root a all over n root a, you can pick the same root and then you take the square root of the both of them. We've already done that. They said if this is root m and root n can give you m times n. Then you take the root of a. I think this is the part that we've not done. Then the n is equal to a root m. You can say n root a, n root m raised to power m. Okay, let me just explain what they're trying to say. See this particular question. I need this particular question. So root 5, root 5 what? Is it minus 30 what? Minus 30 what?
Root minus 31 times 4 root times 4 root 81.
Minus
No,
8 or 32.
minus 32.
Uh, this, if you give me wrong answer, all of us will have the wrong. So let's
Times
look at it.
times 4
So
fourth root of 81.
this can also be written as 32 1 all over. Hope you understand. So anytime you see anything like this, let me say 2 all over 3. This other part goes square root. That's the cube root of it. Then this other part goes as the exponential on top of it. So a question like this is so 3 root 3 then 4. You understand? So understand how these are being placed. Like this other one now, I said fifth root or the fifth root of minus 32. That will just be 2 because 2 times 2 times 2 times 2, 1, 2, 3, 4 times 2 is going to give us what 32. So this is
What about the
1,
minus?
2, 1, 2, 3. I'm getting the 32 first. 1, 2, 3, 4, 5. So with this now we say that 5. Okay, the fifth root of 32 is equal to 5. Remember that there's a minus here, so you put a minus here too. So equal to 2 rather, 2. I hope you understand. Because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So the fifth root of 32 is what? 2. The same thing goes to the other one, which is 81. Fourth root of 81. What do you think that would be? Fourth root of
That's 3.
81. That's 3. Because 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So the fourth root of 81 is equal to what? 3. So that becomes the answer. All right, we'll move over to the next slide. So example, they have 3, 4. Somebody give me this. Somebody give me this. 3, 4, 3, 2 over 3. Somebody give me that. And
3, 4, 3,
3,
2
4.
over 2.
49.
Eh? Raise the
Let's
power.
have it 49.
I just need question, so
You want me
all
to
of us
solve
can solve.
something now? Did anybody ask you answer? Ah.
I thought he
Oh,
said
yes,
that somebody
let's,
should give him the answer to the question. That's what I thought he
okay,
said.
okay, sorry. Let's try to be polite. Madam, let's try to be polite. We can hear differently sometimes, and it's correct. If I ask somebody to give the answer, that was nice. So, what I needed was, I said, give me the question, but it seems you've already gotten the answer, so that's okay. I believe every other person understands.
But
Let's get
please
the
solve it
question.
if
Then,
anybody's not
no,
clear.
343. Okay, thank you for your newness. Thank you for your gentle spirit. 343, 2 all over what? 2 all over what? 3, right? Is it all over 3?
Yes, sir.
So I said this one will always be the square root, and then this one will always be the exponential. So what if we were to do that, then this is going to be 343, then it's going to be square. So somebody check for the square root of
7 raised to power 3.
343.
Cube root, not square root.
Somebody check for the square root of 343. Yes.
7 raised to power 2.
You said
7 raised to power 3.
7 raised to power 3.
7 raised to power 3.
Yes.
Yeah.
7 raised to power 3. Is that what you're saying? It's like your
Root 7 raised to power 3.
okay.
7 raised to power 3.
Square root 7 raised to power 3.
It's cube root now, not square root. Cube root.
Yes.
343 squared is 117649.
That's what I was expecting. So 117
Six
three
four
four
six
nine
six six 649.
649. So if you check the cube root of 117649, it's going to give you 7. That's what I wanted to hear. Because I still needed to buy into their idea. I don't know where they're copying it from, but it's also correct. So are you people copying the thing from somewhere? Let us know.
No, the
So
cube root is 49. The cube root is
okay,
49, not 7.
it's 49,
Not 7.
not 7. Cube root of, okay, it's 49, not 7. I can't hear you.
Is it not cube root of 343?
Which is
No,
cube root of 111.
the 7. The question is
Is it not 7?
343.
Is it not the cubic of 7 times 2 over 3?
No, 343 raised to power 2 over 3. That's the
It
question.
is it is cube root of 343 square. So the answer is
Uh-huh.
49.
That's 49.
49 now.
Is this the 117649, right?
Yes,
So
sir.
the answer is 49. So it's 49. All right. So the other people that were giving me 7 raised to power 3, I don't understand though.
Mr. Godspower, 7 times 7 is 343.
Okay, fine. So if you do that now, you will now say 7 raised to power 3 times 2, because already we have
All
these
over
2
3.
outside. Yeah,
Yes.
so that will now give us 7 times 6. You understand? So check that. Let's check
I
the both
did
sides if we get the answer.
I did
So
7.
this 7 times 7 times 7 times 7 times 7 times 7 times 7 is 0 to 6. 1, 2, 3, 4, 5, 6. Okay, it's the same thing. 1, 2, 3, 4, 5, 6. So 7 raised to power 6 is going to give us 117,647. And the square root of the cube root of 116,647 is, as you can see, if you divide this by 49, divide by 49, and divide by, you understand? That's 3 times. So that gives us the answer of what we were looking for. 49 is the answer. And we'll move over to the next slide. All right. solving radical expressions. They say radical expression is an expression in
Please
which
excuse
variables
me,
get
Mr. Godspower. I didn't get that last part. I'm sorry.
you don't need to get everything. Just take the one that suits you and the one that is easy for you to understand. They gave me 7 raised to power 7. 7 raised to power
This last
3
part, we did not
multiplied
get
by
this last
5.
part. Oh.
Last part is 49. 49 is the answer. 49 is the answer. Our answer is 49. What do you
How
not
did you come
understand?
about that?
So,
Is
sorry,
it
sir. How do you
49
arrive
or
at the 49? The 49, how do you arrive at the 49?
Okay, I'm coming. So we had three. We have cube root of we have 347. Okay, 343 rather. We have we have somebody's mic is on. Please help us. Help us with your mic. Three. We have 3 4. 343. 343. Right.
Yes,
Three
sir.
four
Yes, boss.
three. Yeah,
Yes,
the
boss.
equation was 343 raised to power
Two
2
over
all
three.
over 3. Yeah, this was the question. Now, so this is going to be 343 square. Now we look for 343 square, which is 343 times 343, and that gave us what? What was the answer? One one seven
One one
six
seven six four
four
nine.
four nine. So when you check for the cube root of 117,649 is going to give you 49 as the answer. So that's to test that, you just say 49 times uh, times 49 times 49, going to be 117,649. That's for the check. You want to check. So everything you say you didn't understand. So we can move on now. So radical equation is an expression in which variables are very important. So root 3 2s minus 4 minus 2. We solved this last time. We said this is just to transfer this minus 2 to the other side. It's going to be positive 2. Then you can um, do this the way we wanted to do it. How do you want it? Okay, divide both side by 3. So this is going to be 3 raised to power 3, and then this one. Okay, let's try this question. Somebody give me this question. Somebody give me the question, please.
Yeah, 2x minus 4 all in all is 3
2x
minus
minus
4.
4.
That is
Mhm.
cube root of that, or the 2x minus 4. The square is cube root, not another square root.
Like this.
Yes, sir.
All right. Good. So we said like this now. We say over 3 2x minus 4. And we transfer 2 to the other side of the equation, 2. Then the next thing we do is place this kind of thing on top so that this stays. Sorry, this one will remain. This other person will cancel this. So we're having 2x minus 4 is equal to 2 raised to power 3. Then 2 raised to power 3, we know that the word 2 raised to power 3 is going to be 2 times 2 is 2. 2 times 2 is 4, 4 times 2 is 8. So we transfer this to this other side. So we have 2x is equal to 8 plus what? 4. Then we have 2x is equal to 12. Then this is over 2. So 6. So our x is equal to 6. So that is simple. Now, we move over to the summary. All right. Is there any other thing we needed to touch here? Polynomials and rational. we're talking about what is a polynomial? A polynomial is an expression that can be written in the form of s of n x raised to the power n plus a this that. So there ai is equal to that is the ai is equal that's a plus with n is the coefficient. Then the term is when you add it to the x is called the term. So if a starts with n is equal to 0, then n is the degree of the polynomial. That's whatever is within raised to 10. An is the leading coefficient where you add the number behind the any alphabet there. Then when you have the an, a substitute n s squared is the leading term. So like the leading term. So go to the leading term here. You see the leading term is what they're trying to show you here. The exponential n is the degree, then the leading coefficient is the a substitute n there. So that's just that. Examples of polynomials. So we have x squared, 8s cubed plus 2s cubed, as cubed plus 2s squared minus 4x plus 2. So all these are, so this is a degree 3 polynomial. Leading coefficient is 8. Then the leading term is 8s cubed. So is this difficult if they ask you in your options when they bring it and say, okay, so this, what is the degree? What is the degree of this? Is just take the highest exponential of the x, and the highest exponential of the x there is 3. So the degree there of this polynomial, what degree of polynomial is this? Degree 3. And when they ask what's the leading coefficient, just check the number that's highest degree, the highest degree exponential, which is what 8. And what is the leading term? Leading term is the first first expression that carries the degree of highest degree, which is what 8s 8s3. So don't get confused. Anyhow they twist this thing, you should be able to answer them. So this one now you can see that this one, not when you go tomorrow and then they will tell you x is 1x raised to the power 4, and then you pick the answer. That will be wrong for the leading term. Since it is 1, you will not always have 1 to be invisible, but it's always there. So we take it that once an alphabet is standing alone, there's always an invisible coefficient of 1 beside it. So the leading degree, as you can see there, is 4. And then all these things are simple. They are elementary and basic, as you know. Then combine like terms. Okay, add and subtract polynomials. Combine like terms, simplify and write it term like this. So if they give you something like this, it's very simple. It's not something you should write yourself for, but let's do it despite how long it is. It's just for you to know what your signs are, so you don't make mistakes. So somebody take these questions. I would like to just solve this thing at once so that you see what is there. Any need of solving this thing, they are already written here. I hope you can understand from what is written here. We have 8s cubed, this, that. I hope you understand. Do we get it? Everybody understands this, but it's not a big deal. So we move over.
Sir, please, can you still also explain it for us? Thank you.
It's actually for your kids. It's as simple as you should be done guiding them towards material, all these signs and the rest of them. But you can right. Let's get the first question, please. They call this mathematics elementary, and I'm so just worried. Why did they call it elementary? That was the first day when I started looking at it as something very common. So this is 8s cubed. Can somebody call those figures for me? Somebody call these figures for me. The person.
8x cubed plus 2x squared minus 4x plus 2 close the bracket. So we are adding it plus open another bracket minus x raised to power 4 plus x squared plus 5x
clear the bracket.
All right. This now all we need to do is just first of all let's deal with it. Let's deal with this. Let's move through the bracket. So this is going to be minus. In fact, I'm opening everything. This is going to be 8s cubed plus 2s squared minus 4s plus 2 minus s squared plus s squared. Sorry, minus s. I'm multiplying the minus. Wait, it's not minus, it's plus that is outside. So plus times minus is minus, plus times minus plus s is also plus s squared. And plus times plus for 5x is also 5x. So we check which numbers are having the same power ratios. 8x, 8, which one is the highest? Our degree, the highest degree there is 4. We bring it first, then plus seconded by s3. Then we have S2. We have minus 12 S2. We also have S2 here too. So we take plus S2. Then the next one is X. Here we have minus 4X. And then we have X here too, which is plus 5X. Without having another thing again, plus 2. So if we check that now, this men give us minus 12 minus x is going to give us minus 11x squared. Then also this meant plus 5 minus 4 is going to give us only 1x. So rewriting this, we have s raised to the power 4 plus 8s cubed minus 11s squared. Then this will be positive x, then plus of that particular
Mr.
question.
Godspower, sorry, 2x plus
X,
x is minus
X is power
11.
4 is negative.
You said
How did you get 11 minus 11x squared?
minus 11, where we have minus 12s squared plus s
No,
squared.
it's
So it
minus
depends.
2x,
Is
not
it
minus 12,
12x
sir.
or 2x?
2x,
Is
sir.
it minus? Oh my god.
Sorry,
Is it
minus
2s?
2x, sir. Yes,
Sorry.
sir.
And I brought, is it minus? It's not even minus. It's plus 2x. I thought it's minus. This is supposed to be plus 2x. So if it's plus 2x, where do we have it? This is plus. Then where do we have plus? Okay. Sorry, my writing had us confused. So instead of 11, this is going to be plus 2x plus s is going to give us 3s squared. So this is going to
Mr. Godspower, I think that
X
X
is power 4 is negative.
is minus at the front. I think there should be a minus at the front.
Yes.
there should be a minus as here.
Minus x
At the
raised to
front,
power
X is power 4.
Minus 4.
minus x raised
Minus
to
X is
power 4.
power 4.
This fine. This
As
the
in the
final
beginning
answer.
of the equation
Okay.
number, as in 4, for x raised to power 4 should have minus x raised to power 4 instead of just, yes.
Yes, because looking from that equation.
Thank you for all this. I think all these things are oversight. I can understand when they are oversight, but they can actually fail us. Oversight is not considered. So this becomes our answer, right? Confirm what we have. Yeah, this is what we have minus this. Okay, we got that. Minus this plus this. Okay, so you just have to do the other equation just the same pattern, and then that will be all. Multiplying polynomials. Okay, we're multiplying polynomials. We multiply each time. This thing is long. Find this and that and that. Okay. Give me this particular question. Let's solve that one. Then we'll be flipping the other ones. Somebody give me the question, please. Please give me the question. I thought somebody's giving me the question.
Bracket 2x squared minus 4.
Mm-hmm.
Bracket minus x raised to power 4 plus x squared.
Plus what?
5x. Plus x squared plus 5x.
Is that all?
Yes.
Okay, this is just to say 2x squared. Please follow me up also so that I do not make mistake with my sign this time. Just just thinking of how many things we have to do this night. So this will multiply, and then also minus 4 will multiply plus 5. Just know that this is 5x. Since my writing can't do that. So 2x squared multiplied by x raised to power 4 is going to be 2x what? 6. 2 times 2 times 4 is going to be what? 8. Then plus 2x squared multiplied by x squared is going to be
And
what?
my
2x.
x is you
said?
there is negative minus 4 minus x is power 4. It's negative.
X raised
Okay.
to power 6, not
Yeah,
4.
thank you.
X raised to power 6. Minus
You said?
2, it should be minus 2 x raised to power
Raised to
6.
power for
Not
adding the
Okay. Sorry,
not
sorry.
subtract.
The indices. Oh my goodness. 2x
and there's a minus in front.
Okay.
Plus 2x raised to power 4 plus 10x raised to power 3. Is it plus so?
Okay, understand. This is over 1.
2 times 5.
This is over 1. So 2 plus 1 is the one that is making it 3. So the other part is going to be then minus
No
4
plus, no plus is a plus, minus times minus.
minus times minus.
Yeah.
Let me add this. Am I in this class at all? People should excuse me. I know where my mind is. Sorry, just yeah the
Mr. Doctor, go and check your money before
Abi.
foreigners leaves it.
I beg. No where my mind. That's why my mind is not there. Sorry, we're entering a new week, so the market can be like this. Okay, I'm still on pause. Alright. Sorry, let me just set the timer. Take this out of the basket. 7. Coming. Just want to put a boundary. 7. Okay. All right. Thank you so much for your patience. I believe we are together now. Can you see my screen?
Yes, sir.
All right. So this is yeah, and 4 plus 4 is going to give us 8. Then I didn't even put the x. Then minus 4 times
The
4
minus
there is going to give
is
you minus
minus.
4.
It should be 4x raised to power 4 now.
It's
Before does
minus.
not
I'm
before does not have any x in front. Plus 4x raised to power 4.
4x raised to power 4.
So this is
Minus 4x
4.
squared.
4 raised to power 4
And this other one is minus.
x raised to power 2.
Minus 20x. Minus 20x.
4x raised to power 2.
Minus
I think
4s squared.
20.
That s squared, I think it's supposed to be minus
Minus
4s.
4x raised to power 20.
All right.
Thanks.
What is our leading coefficient here now?
Minus
Our
2x.
degree is
Minus 2.
the highest. The highest here is s raised to power 6, right? So we
Yes.
bring it down here. Say minus 2s raised to power 6. Plus the one that follows is plus 2x raised to power 4, followed by
Plus 4x raised to power 4.
4s raised to power 4, followed by
Plus 10x
plus
cubed.
10s cubed, followed
Minus
by
4x squared.
minus 4s squared, then
Minus
followed by
20x.
minus 20x minus 20x. So if we do this very well, okay, this man has to go. Plus 2 plus 4 is going to give us 6. So this is going to give us minus 2s cubed,
Raised to power
then
6.
plus 6s
X raised to power 4.
4, then plus
Minus 10x
10s cubed, then minus 4x, then is the other one minus 20. Yeah, 20 is minus 20x. So this becomes our answer. Wait to
minus 4x
10x.
squared.
Is
4x
this
squared.
square? 4x
Minus,
square?
yes, sir, minus 4x squared. Not just minus 4x.
Because I want fine. If I would have added to final answer. Do you have a problem with that? No. Okay. I think we are done with all this. Okay, was it even solved here? The minus 26 raised to power x plus 6. Uh, uh, yeah, why was I solving it again? Look at me, waste of time. All right, using foil to all this foil first outer tense inner atlas blah blah. Hence, the example your x plus this and multiplied by this, giving us quadratic equation here. Then this other one is giving us quadratic equation here. So we can do all this now. So once you give a quadratic equation, you can find the roots of the equations. So what they have there. And a binomial is squared, the result is called a perfect square trinomial. This is what we were trying to get in using that perfect square. The difference in squares, this and that. So I want you to understand this. Please check this very well. Once you have a plus b raised to power square, just memorize this. The answer is going to be a square plus 2ab plus b square. So had it been, we have, oh, my shouting. Yes, somebody sleep. Had it been, we have a to the 2, then we have b to the 3, this square. So our answer here is just going to be a square. Yes, 2 square is going to be what, 4. Then say plus 2ab. 2ab. That's if a is 2, b is 3. 2ab is going to be 2 times 2 times 3, which is going to be what? 2 times 2 is 4. 4 times 3 is 12. So our 2ab there is going to be what? 12. Then our b square is going to be what? 3 square, which is what? 9. Our answer would have been 4, 12, 9. So it's going to be 4a. Just understand what I'm trying to say. That's all. If you have the minus, it's just to change that initial sign to the minus. Then you're good to go. Also, if you have them like these two, a different squares, now we have a plus b all over a minus b. If you do all these things, you still get this answer. So no need of memorizing something in your head. For example, they're giving us example now. This s plus 2 square. S plus 2 square is just taking the loop of this form. It's taking this loop, a plus 2 square. So you can see the answer yourself, even without writing too many books, that s plus 2 square is going to give us s square plus 2 plus 2x plus 2 that's 4x, s squared plus 4x. Then the other one is going to be plus 4.
Plus 4.
So that would be plus 4. So that would be the answer
So
of the
is it
first
not
question.
4x squared?
S squared, yeah. It's going to be s squared. No, not 4s squared, sorry. That one, the pattern is 2ab. It's not, so only the first and the last has the square. So it's supposed to be s squared plus, if you check 2 times a is x, b is 2. So 2 times a,
It's
2
4x
times s2 is
plus 4x
4x. You
plus 4.
understand? Then plus 4, because 2 square is what? 4. So that's just a short form of getting. So no need of solving too many things. Just do that. So check the second one too. It's in the same form. Here we
9
have
squared
3x minus 5. So the 9x, that will be 9x squared. That's the first time. Then the second term is going to
minus
be
30x.
that's 2 times 3 is going to give us 2 times 3s is going to give us 6s.
No, minus 2.
6s times 5 is going to give us. Are we getting it wrong? Oh, now.
No, it is minus
3x
2ab. It is minus 2ab.
Let him
minus
talk. So that
2ab. Okay, yeah, it will be minus because of the sign inside. So it will be 6s squared minus 2 2 times 2ab. A is 3x, b is 5. So 2ab is going to be 2 times 3. 2 times 3s is 6s times 5. So 6s times 5 is going to be 30x. So it's going to be 3x squared minus 30x, then plus what? Plus 25. That would be the answer of the second one. I hope you are getting what we are trying to do here. Is anybody confused? We are using this simple formula to just, instead of solving too many things, just memorize them and can easily get your answer. This other one is to just open the bracket and then you get the answer. Like they say,
So,
if it is a
sorry,
plus
what's the
b
answer? What's the answer
and
you
a
want to
minus,
solve now?
the one we solve now is 6. You said is 3 is 9x square 9x square then minus 9x square minus 30x then
Plus
plus
25.
25.
Thank you.
Hope you got it. Because the other time we were saying 3 square s square, but 3 square is the same as 9 is 9x. So yeah, so that one 2s times 9 2s equal to 4s. All this one you can do all this anyhow. Factorization using special products. All this one is quadratic equation. Factorize the following using special products. So use a quadratic formula. Who does not know quadratic formula? Anybody who doesn't know quadratic formula can't wait to memorize. Is there anybody that does not know quadratic formula? Oh, but so you can solve this, solve all this is what we special products again. Some of you okay. They are giving us another shortcut here when we have a cube plus b cube. So you have a plus b, then you have a square minus ab plus b square. Then you have a cube minus b cube is minus a minus b. Then the whole of the other side is going to plus plus. And they're saying remember so which is same opposite always positive. Same opposite always positive. Hmm. Can you memorize this? If you can't memorize, simple, just do the normal factorization and then let not be like you're memorizing something and you forget it. Just open the bracket normally and you get this answer. Simple as that. Factor the following. We have SQ plus 64. SQ plus 64 is taking the root because this now is 64 is going to be 64 is going to be what? Is it not 3 root 3? So if this is 3 root 3, then it's going to take. Let's solve this, please. Somebody give me this question. Remember this. Remember this. A plus B is going to A plus B, A square minus AB plus B square. And then let you have minus going to be A minus B. Then you have A square plus AB. All right. Somebody give me these questions. So I want us to do this particular part.
X cube plus 64.
S cube
Plus
plus
64.
20
Plus 64.
64. Now we know that this 64 is 3 raised to power 3. So we change this to S cube
Oh,
plus 3 raised to power
this value is 27,
3
not
times
that's
3
27 now.
is 9. 9 times 3. Okay, so it's 4 raised to power 3. Here we have 4 times 4 is 16. 16 times 4
64.
equal to 54, right?
Yes, sir.
This is 4 raised to power 3.
3.
So with this now, by the formula, what they were giving us is just take this to be A, take this to be A
Plus B.
plus B, and then this will be
A
A
square
square minus
minus 2
AB
plus B
plus
square.
B square. And if you do that, what is A? A is what? S cube. B is what? 4 cube. Then we have this will be A square is what? X
So A is A is just X, not X cube. You leave the power out.
we leave the power out.
Yes, sir.
Okay, coefficient of
So it should just be X plus
A
4.
square. So it will be X
Plus 4.
plus what?
X plus 4 for A plus B. The power not be, you will not include the power.
Okay, like this.
Yes, sir.
I'm saying
No.
that
I'm
is out.
talking about the second line where you have X cube plus 4 cube. Should be X plus 4.
Sorry, it's an error. This one back.
Yes, sir.
Okay, sorry. So this other one will be S cube, S cube square. So this will be S cube square minus
Okay.
X times. So this will be 4x, and then A F 4x cube and plus B will be what? B will be 4 square, right? So this will now be S is S. Wait to need to confirm something. Okay. Truly, they didn't carry those powers. So this thing I'm doing is wrong. Plus 4. Then this one will not be. If
X
you
to
can't
power
memorize this thing, me, I don't want to memorize anything that will give me problem.
x to power
Eh?
2 x to
X
power
is fine.
2 minus 4x plus 4 squared.
S raised to power 2.
Yes,
Is
sir.
X is
That is it's not even going to be the main X. This is already solved. 4x plus
16
16.
4 squared.
this is also 16. X or x squared minus 4. I beg. If not only me, I'll do the long process. Let me just get. I don't want to memorize anything. We will give. We will give me problem. This other one, it's S cube and
Wait, sorry,
27.
please. Can it be done again because I didn't really get that long process.
You try
I'm
to
sorry.
understand each other. Yeah?
I didn't really
Who did not
understand.
get
Um,
memorize this? People who are good with memorizing things. As for me, I want to solve the long process, but it will take time. So what's the point? Just memorize this. Whenever you have something hard, a square, a cube plus b cube, just carry this formula and keep on the ground and put them inside. As simple as that.
okay.
Now we want to do this other part that they say a cube minus b cube. The answer will look as a minus b, and it's going to be a square plus ab plus b square. So check this question now. This particular 8s cube minus 24, 27 rather. We want to use the second formula tip that they gave us there. If you do that, remember that what do they have there? Is 8 what? 8s what? 8s what?
8x cube minus 27.
Minus 20 minus
7.
27. If you check this, 8, you can change this also to 2 cube x cube, then minus 3 cube. I think
Cube.
3 times 3 9, 9
Yes,
times 5
3 cube.
cube. So that all this can be 2x minus 3 or cube. So now we can go. We can go with our answer. The formula for this, they said this one will be a minus b, right? Or let me write it down. A minus b. Then the other side will be a square plus ab plus b square. So this is what we have. So we are plugging a now into this. So this will be 2x minus 3, and then this other part will be 2s square, you know, then plus 2x times
I think it will be
2s
minus
times
so minus 6x.
minus 6.
Yes, minus 6x. You know they say that side is
Minus,
AB, so it will be like 2x times 3.
it's not supposed to be minus. So I checked very well. This particular one is plus. Look at it now. Look from the formula. Right?
Okay, I understand now. Thank you.
Okay. So this is 2x multiplied by 3. So if you check 2x multiplied by 3, and that's the AB. Then the plus B. The plus B will not be what? Plus B square. B square is, sorry, B square is 3 square. So if you open all this now, you will have this to be 2x minus 3. That's the first side. And the second side is 4x. Then this other side 6x. Then this other side will not be 9. So this becomes our answer to that particular question. I hope you understand. Hmm? You can memorize this fine. If you can memorize, do the normal this times this times this. You understand what I mean? The normal one will be 2x minus 3 multiplied by 2x minus 3 multiplied by 2x minus 3. If you open this bracket the same way to give you this particular answer, take this to this first to give you 4x minus 6x, and this one minus 6x, then this one is plus 6x. No, just do this thing like that, you will get there. Because the process is long, so that's why they're telling us memorize formula, then you can go. Anything we need to like have fun and change with the off now. All right, we're done with this. Okay, factoring a trinomial with leading coefficient. Trinomial is quadratic equation, so you can use quadratic formula for this. Don't waste your time. Don't have time to waste. All these quadratic equation. Okay, wait. Remember when I was trying to give us a factorization of quadratic equation? They said look for two. Oh, thank God, there's peace. Wow, generator with this noise. Um, when I was trying to when we were talking about quadratic equation, see you have to look for two numbers p and q such that when you multiply those two numbers, they give you the like for this one now, this 8 now. You look for two numbers such that if you multiply them, they will give you 8. And then when you add them together, they will give you minus 2. And what are those two numbers? If you check those two numbers, oh, first of all, we have to remove 3 out of the way first. So, hey, go there now to confuse you. Use quadratic formula and go. We've taught all this. Today is not teaching them. Today we wanted to teach to all this and we've taught them. So use quadratic formula and then you go. If not, this is just to divide both sides by 3, or you multiply the 3 by the 8. And then you look for two numbers that when you multiply them, they give you. Okay, let's do that together. 3 multiplied by 8 is going to give us what? 3 times 8 is
minus 24.
Minus 24. So look for two numbers that if you multiply them, they will give you what? They will give you 24. Those two numbers will be what and what? If you multiply them, they will give you 24.
That is 6 and 4.
6 and 4. Okay. And
minus 6 plus 4.
Yeah, minus 6 plus 4 will give you
minus 2.
24. And then if you do that, if you add them together, it will give you minus 2. So we are going to come and use that. Give me this particular question. Let's solve it out. 3x squared 2 minus 2x and 8. Let me see if I can. Please give me I don't memorize numbers. 3x squared minus what?
Minus 2x minus 8 equals to 0.
2x minus 8
equals 0.
So with this now, we found our P and Q. We found our P and Q to be what? Minus 6 plus 4. So these are our P and Q, because minus 6 is going to give us 24. So this is going to be like 3x squared. We are going to now make use of minus 6x plus 4x minus 24 equal to 0. Why we are making use of that is because we want to make sure that this 3 times 8, because 3 times 8, anytime you have the leading coefficient above 1, then you have to multiply that leading coefficient with the constant. The constant is the one that does not have an x. So if you multiply that, it gives us 24. We will now start looking for instead of looking for numbers that if you multiply the both of them, will give you 8, we are now looking for number that multiply both of them will give you 24. That's how we came with this number. So if you check this now, if you pick these two together, pick these two together, you're going to you've gotten what you wanted. So this will give us 3 here. Then this will be okay. We take S2. So this one will be x minus what 2. Then this one will be we pick 4 here, and this will be x minus. So are we doing the correct thing here?
No, that's -8, not -24.
Yeah, it's supposed to be 8.
-8, 4x minus 8.
Minus. Okay,
The
sorry.
constant.
4x minus 8. So this is 8. Yeah.
No, that would be 2.
Sorry. This that is 8. This is 8 minus 2. What was that? What did I say wrong? We were supposed to take 6 and 4, and then we'll come back with this because we are making use of this. Okay, only when we remove this, that's when we'll work with this. Alright, I understand now. This is 8. I don't cancel everything. I hope we understand though. People who don't get this now, I'm in trouble. I hope you all understand. Do you understand? Every other person, do
I
you
don't really
understand?
understand.
This is the question, eh? So we got the two numbers that if you multiply them together, see this question, I think this question is x squared minus 2x minus 8. This is simple because we don't have anything around this x. But since we have a number 3 behind that x, so now say, okay, 3 times 8, it gives us 24. Now we look for two numbers that when you multiply by 24, when you multiply by 24, you okay. When you multiply find two numbers and when you multiply by themselves they give you 24, and then when you add them they will give you this middle number which is 6. And so and those two numbers we found them to be 6 and 4. So we'll now use now come back and say 6x squared then 3x squared and minus 6x. We are using the since it has the coefficient of they are all the both number are coefficients of x. So we say minus 6x then plus 4x. Then we use the minus 8 there in the equation equal to 0. Then we just bracket the both side of bracket the two sides and pick the common like terms out. Common like terms will now be 3x. Yes, we are checking for things that if you that you can easily go into the two things, and we found that 3 can go into 3 and 3 can go into 6, and we found that x is in the both sides, so x can also go. That's why we pick those 3 outside. We pick those two outside, and by that we now have only x remaining here because 3x going to 3x squared, only x will remain. Again, if 3x going to 6x, x will cancel x, 3 will go into 6 to be 2 times. So we have that as this. So we also look for among 4x and 8, what can go? There's no x on the other right hand side of the equation. So we took only 4 out because 4 here, then 4 going to 4x, to remain only x, and 4 going to 8 is going to remain 2. So that now gave us this. So we are now going to take 3x plus 4 as one part of the equation, and then we take x squared, x minus 2, which is this part of the equation to be this. So our x is going to be the first equation 3x plus 4 equal to 0. Our 3x is going to be 4 all over. So this will be over 3. So our first x is 4 over 3. Then the second one is x minus 2 equal to 0. So our x is going to be transferred 2 to the other side of the equation. If you transfer 2 to the other side of the equation, so this is going to be s is equal to positive 2. So our x is either 2 or 4 over 3. I believe we understand that.
Mr. Godspower, please put your finger there. Can you hear me?
Mr. Closer, it's supposed to be -4/3.
Is it not -4, please?
minus 4. It
Whenever
can
you
be,
move the 4 to the 0.
yeah, yes, it's true. There is minus 4. So that's the answer to that. Your eyes are sharp, and I like that. Well done. I think that should be in the accounts department. The eyes are always sharp. Well done. Um, okay. Degree polynomial, this, that. I think we're done with all this. We can solve all this now. We can solve these ones too. Rational expressions. This is the one that we did last time. When you multiply rational expressions, we can do all this now. We can also do all this now. Simplify this. This, that. Blah, 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 blah. No, bring them together. Look for number that going to three of them. So we
Hello,
took
sir.
three. Yes, sir.
Sorry, please can you solve this particular question, this 9x square? I tried solving it earlier, but I was having some difficulties, even with the
Call,
solution there.
call it for us. Call it for us. Let's get it.
9x square
9x. Mm-hmm.
plus 6x
Plus 6x. Mm-hmm.
plus
It's called the correct one. You call the wrong
let's
one.
say 9x square
Call
plus 6x minus 3
what?
minus 3 divided by 9x square minus 9. Okay, that is it.
So if you want to simplify this now, you check for number that can go into the both of them. And we have already seen that this 3 can go here. And so also here, 9 can go here, can go here. So what do? We just come here and say 3 brackets. 3 going to 9x is going to give us um, 3 9 square plus 2x minus 1. And then this other one is going to be 9. Then this is going to give us s square minus 1. So if you check this very well, you see that this 3 here can be 1, this 3 here can be what? Can be 3. So we come back here and write this is 3s square plus 2x minus 1 all over what? All over 3 brackets s square minus 1. So if you check this again, is this not the answer? Remember, just remember, this is almost like a quadratic equation. If you find the quadratic equation for this, what is it going to give us? What is this going to give us? What is going to give us two numbers that if you multiply the both of them, they will give you 1, but if you add them, they will give you 2. Those two numbers, okay, first, 3 times 1 is going to give you 3. Two numbers that if you multiply them, they will give you 3, and if you add them, they will give you 2. What are those two numbers? It will be 3 and 1, right? So that will be positive 3 and minus positive 3. That is positive 3 and minus 1. So that if you add, if you multiply them together, they will give you positive 3, and then if you if you multiply them, give you a negative 3, and then if you add them together, they'll give you positive 2. So we take that particular up one. We take this 3x squared plus 2x minus 1 will be in this format. It's going to be 3x, then what are the numbers? Plus 3x, then minus 1x all over minus 1. So with this now, if we take this together, we understand that we take 3 out, 3x together. 3x going to this is already, this is 1, 1, right? This is 1, 1. 3x going to, or instead, let's just combine this, and then let one go with this. Okay, so it will be 3x. Sorry, 3x minus 1, and then 3x minus 1. So that if s comes outside, this is going to be s minus 1.
X comes out
Not even
3
supposed to.
minus 1.
3 minus 1, yes.
So you see that this and this are the same. So instead, we just say x
Because 3 minus 1. 3.
bracket
3.
s minus
The
1.
3 is missing, sir.
So that is it, s minus 1 all over.
The 3 is missing.
Okay.
It's supposed to be x
Is
bracket
it
3
X
minus
minus 1 or 3 minus 1? S comes out 3 minus 1 in the bracket.
Yeah, something is that I am not getting. 3x minus 1. So if 3 comes out, if s comes out, it's going to be 3 minus 1. And then, okay, this is going to be, no, instead 3 will come out. Instead 3 will come out. Oh no, this will be s minus x. Sorry, let's do this. Let's take this
x.
part again. What did we not do here? This is x, not even 1x. So this, I don't know what to do here, because this is supposed to be 3x plus 3x, and this is supposed to be x
Sir, yeah,
plus x. Yeah,
in that bracket is meant to be 3x squared plus 3x. So it will not be meaning x plus 1 here. That bracket will be 3x squared plus 3x
3x squared.
plus 3x.
Okay, 3x squared plus 3x.
Yes,
Okay, sorry.
yes.
So,
So if you now use 3x to open that bracket, it will not be complete.
okay. Once you miss a step in mathematics, that is how this will now be x plus
1.
You still square the x
1.
outside.
You're able to
So
fit
this
the x
other
outside
one,
again.
The square is not supposed to be there.
sorry. Sorry. So this other one is minus. If I take minus x, so this will
So
now
minus,
be, I want to take
no sir,
minus
it's be
s.
minus 1, sir. No sir, it's be minus 1.
Okay, minus s will not go, minus 1. So that this will now
Yes,
be positive
x
x,
plus 1.
and then this will be positive 1. So now this and
Yes,
this are looking alike. So this is 3x minus 1, and equal to 0, and also x plus 1 equal to 0. X plus 1 is going to give us, this will give us minus 1. Then this one will give us one all over 3. So what did they now say now? If you are to do this, x plus 1. Okay, well, how do I solve this matter now? S plus 1, let's see what it said here. 3x minus 1.
Well, yes, mate. Don't worry now. I've gotten it, sir. Thank you, sir.
Okay, they cancelled.
Yes, they after they factorized the numerator, they now factorized the denominator. After they did that, they now cancelled out the ones that
S
were
plus 1.
similar. And now that they got this finally. It was
Yeah,
just
the
that
S.
factorization for the one that was having some
Okay.
problem. Thank you, sir.
So it was they cancelled that s plus 1 out. So we're having 3x minus. So they didn't even go to look for the root. So because I just went to root. I went to look for the root, and they didn't go to look for the root. So when they got to that extent, they just cancelled.
Yes, sir.
So we are good to go,
Yes,
and
sir.
we can
Thank you,
go
sir.
now. Just memorize the answer. As I am now, I don't need to solve many things. If I see some answers that look alike, I memorize them. Like this particular, where's that question again, sir? Where is it now? Where's the answer? 3x minus 1, then 3 bracket x minus 1. It's simple, sharp, we will know it. This other one, x plus 2, x minus 1, we will know it. These are simple things. See, all I'm trying to do here is not actually to solve everything correct. Just giving you the idea those you can use to solve, so that by the time you see them, you yourself you can scrabble something on paper, and then you can go and get out of that hole with the success, with high success rate. Example, this all this are just time wasting. Thank you. We are done. Oh, what are we doing again? So
Sequence.
where we are.
I yeah, I think so. Because that's the next one.
Quadratic equation is the next one because you can.
Okay, yes, that's
Okay, so we go over to quadratic equation zero this that. Hmm. Are we still together? How many people are still there? I hope you are not sleeping now. Let's endure. That tomorrow will be free. I want to ask another question. Hey, nobody's sleeping. Hmm. Mathematics, nobody wants to sleep. All right. Well done. So we start with learning objectives, solving quadratic equations. Any equation that has an as squared plus bs plus c is equal to 0. You see, where that woman was using the other quadratic equation last time to solve and had no c's. This was where I was coming from. That quadratic equation have to have a c. Though the answer still gave her the solution she was asking for. But my dear, why go to use quadratic equation when you don't have a c? Don't stress yourself. Use another formula. It's called the square root property method. You will see that formula. So quadratic equation, before you can use quadratic, it has to be in this form: as squared plus bs plus c. You know that plus bs can also change to minus bs. All right. So we have these. Who does not know quadratic formula? Okay, factorization. We know factorization. How we say for this particular one, now you look for two numbers, and when you multiply them, see how to get simple answer to this. He didn't put it here. Okay, in the video, he said the answer to this root is just the opposite of those two numbers. The opposite of those two numbers are just the answer to this particular question. So when you find the roots, the roots are the P and Q. Like for this particular one now, remember we said look for two numbers. What will be the two numbers that if you multiply them, they will give you 2? And when you add them together, they will give you 3. That is simple now. Any woman can tell us this. Any child can tell us this. 1 and 2, right?
Minus 2.
1
In
times
this
2 is
case,
going
it
to
will be minus 2
Minus
minus
two
1.
minus one.
Yes.
yeah, because
Minus
if you
2
add
minus 1.
yeah, if you add Now, if I say add now, some people now get confused. Yes, if you sum or because they're in the same number line, you bring them together. Let me know if you sum. You bring them together, they'll give you -3. And if you multiply them together, minus times minus will give you +2. You understand? So if we check those two numbers now, we have minus. Let me use my writing board. Can somebody give me those two questions? Give me that question again. It says S what? S square. What was the next thing?
X squared minus
X
3x.
plus 3x plus 2 is equal
3
to
plus
0.
2. S squared minus 3s plus 2 equal to 0. Now we found our P and Q to be what? To be equal to -3 and -2. So the root of this equation is simply x is equal to +3 or +2. How do I get this answer? Just get the opposite of this. Get the opposite of the P and Q. And that will be the root of the equation. How? Let's check and see whether we are correct. So this is s squared, and this other one will give us -3x, then minus 2x, then plus 2 equal to 0. And then we'll take this 2, and this will now be x, and this will be x minus 3, right? And then this will be 2, that this is, sorry, this is minus 2, so that this will now be x minus what? S minus, did I get this thing? Look at me.
Minus 1.
I didn't
P
get
and
this thing.
Q.
I have to change. P and Q is what?
Minus 2 minus 1 now.
-1. It's not. Yeah, -2 minus 1. No.
Mhm.
-2 minus
Minus 2. No?
2 minus 1. When you make mistake in this sense, you are sure to have issues. -2 minus 1. You're sure to have issues, and that's why you see I was suffering here. So this one now, minus x, and 2 going to be 1. Correct. So thank you. So this one now, s minus 2 as 1. Wait, I'm not still getting this thing the way I'm supposed to get it. So
Let's start all over. So I forget.
Igwe. Thank God. We will soon see the next day for our massive. All right. So this now we said this one is P is -2, and then Q is -1. So if you check that, it's going to be s squared, then -3 minus 2x minus 1 minus x plus 2 equal to 0. So if we take these two, take this. So this will now be x bracket x minus 2. And if we take minus 1, this will be x minus 2 equal to 0. So this will now be x the same. This will be x minus 1 the positive 1. Then we have x equal to x minus 2.
Please mute
Somebody,
your mic, oh,
please,
Mr. Kola.
somebody, your mic is. So this is x equal to the answer I was giving before that. Once you find the p and q, just check for the opposite of this equation. So I believe I've explained that for your understanding. Thank you. Okay, we need this one also. So let's check for this. What are the two numbers that somebody give me this particular question? 4x squared. Somebody give me that particular question. 4x squared. Somebody's mic which is on and is not giving me the answer. I should mute the mic, please. Mr. James, are you still here? Thank you. Thank you for muting the mic. So with this now, what we are going to do is multiply first of all 4 times what 9, and that will give us what 36. If I'm not mistaken, am I correct? Yes. So look for two numbers that when you multiply them together, they will give you 36, and when you add them together, they will give you positive 12. What will those two numbers be? Somebody please give us the two numbers.
6 and 6.
6 and 6 will give us 36. So 6 times 6. So we take this as our P, we take this as our Q. So we've gotten our Q and Q. And in what format will they give you? It's positive, positive, because positive, so let's say positive 6 multiplied by positive 6 is going to give us 36. And 6 plus 6 is going to give us 12. Now I told you that once you get the what they call root, not to get the p and p like this, just know that the root of the equation is going to be the opposite. So the answer of this is supposed to give us minus 6, and the answer of this as the value of what x. How? Now let's find out if that is true. We don't need to find out because we've already done that before, right? This is 4x squared. Then we have plus 6x, then plus 6x, then we have plus 9 equal to 0. We bracket these two out. We are going to have 2 bracket 2x squared plus 3x, and then we have 3, which is 2x plus what? Let's take this as 4x so that this x will go. Sorry,
2x rather.
2x rather. This is 2x, so that this will be what? This will be 2x, then plus 3, and then this one will be 3. This one will be 3, so that it will remain 2x here plus 3 go here is 3 equal to 0. So if you check that, this and this now are looking alike, so we say okay, 2x plus 3 equal to 0. And then we have 2x plus 3 equal to 0. And this is going to change. This first one is going to be 2x equal to minus 3 all over 2 all over. Wait, what is happening? This is also this is also 2x is equal to minus 3 all over 2 plus 3 all over 2 Okay. So, hey, Alan, um, S is equal to minus is it all over 2 or minus 3 all over 2? Wait, there's something you're not. Okay, so that one will say 4 times x is 4 times x. So if you add the times 4 here, this will give you minus 12 all over 2, and then minus 12 all over 2. But this going to this is 6. This going to this is 6. We have 6 here and 6 here. So the answer can either be this 3 all over 2 or that. Okay, so we've gotten the value of x. All we're doing before was this, yeah. So I want to confirm something. Everybody understands this, right? I don't think so. Okay. When we got that 6, we did not turn it into, because we were dealing with, remember we were dealing with 4 times 9. So we're supposed to turn this back to minus. So it can either be this or this. Still the same thing. They'll still give you the same answer. But it's not supposed to, because what they asked us is x and not 4x. So this is supposed to be minus 3 over 2. Now I just got the secret here now. I believe everybody understand what we just did here. Do you understand? Everybody understand. Silent means yes. So I continue. I hope I'm not muted out of the class. Can you hear me? Can you hear me? Please just give me a feedback.
We can hear you, sir.
Alright. Thank God. That means everybody understands. See, so quadratic is not. I was very conscious about quadratic is a simple part. So I believe that everybody understands quadratic. And as you can see, we are going. And this is the question which I was trying to say the square root property that other lady needed to use. Since there was no c given here, there's no c given here. You can see that. In fact, let's solve this. 2x, this 2x minus 1. Just transfer 1 to the other side. It's going to be plus 1. We add 7 to that. Is going to give you 2x. It's going to give you 2x squared equal to 8. So when you have questions like this, now if you transfer 8 to the left hand side, you are going to be having 2x squared minus 8. When you have questions like this, just use square root property. I know the other one that time had an x to it. Meanwhile, this one does not have an x. I think that's the reason why you took it over for that equation. Nevertheless, when you now have questions like this, you take the square root of the both side. When you're taking the square root of the both side, you add your plus and minus. So the answer is plus. Oh, yeah, really tired. All right, we are done. Completing the square. Hey, Baba of them. Hey. All right. Who does not understand completing the square? If everybody understands, then I'll go over. Completing the square. We all understand, but somebody say yes now.
I
Yes,
don't
yes,
understand though.
Okay, where did you say yes?
yes, we do. I do. Yes, I said yes, sir.
Oh, yes. I'm happy. Anybody who has been following the class should understand square root property, and completing the square because we've done this over and over and over. Okay, let's just pick this. Just that the way this man did this thing, I want to follow this and make confused. Okay, completing the square. Somebody give me this particular question. Give me this particular question. Hope I can still remember all the
Four
process.
x square
4s square,
4x
4s
squared
square.
minus
plus
8.
Uh-huh. Is it minus or plus?
Minus 8x.
It's minus 8x plus 3.
plus 3.
Uh, minus 8x minus 8x plus 3. But now the
Equal
first
to
thing you
0.
do, yeah, the first thing you do is to transfer this 3 to this other side. So you're going to have 4x squared minus 8x equal to minus 3. Second you do is divide both side by. So this will cancel this. One that x is standalone. So we have x squared minus 8 all over 4 is going to give us 4 over 1. This is 4. This is going to give us 4x and equal to what? Minus 3 all over 4.
2x.
2x.
So
Second thing we have
2x.
2x.
2x, sir.
2x, not 4x.
eye is clear. I think say I don't cover. Some people don't sleep. Boy, mathematics strong. Well done. All right, then the next thing you do here is to look for the half. You say find the half of this coefficient of x. What's the half of 2 all over? So if you find 2, the half of 2 is going to be what? Half of 2. So 2 times half is going to give us what? It's going to give us 2 all over 2. Half of 2 will be what? The 2 over 2 is going to be, this is 1, this is 1, so it's 1. Half of 2 is 1. Now they say add the square root of half. So add the square root of half of that coefficient of x to both sides of the equation. So this other, the right hand side is one side, the left hand side is one side of the equation. So this is going to be x squared minus 2x. Here we add the plus 1 square, then minus 3 all over 4 plus 1 square. 1 square is the same thing as 1. So no need of writing all those things. I'm just writing parity. So if you do this now, what you have to do here now is that square root. You see that thing we passed last time that it says square root. When a number multiply themselves, you get a square root trinomial or whatever in English. It's called complete square. Complete square is to take this down, take the sign down, then take this man down. It's going to be one square. So if you do that now, if you do that now, we take this other one. This is going to be minus 3 all over 4. Square root of 1 is 1, so this is 1 all over 1. If we do that, it's going to give us 4. 4 divided by 4 is 4 minus 3. Minus 3, 4 divided by 1 is 4. 4 times 1 is 4. So minus 3 plus 4. Minus 3 plus 4 is 3 plus 4. 4. All right. Oh, okay. Minus 3 plus 4, we know that to be minus 1 all over 4, right? That will be the answer here. So we come over here and say, since this one is square and this is square and this is square, we take that square root outside and then we say s minus 1, we put the square root outside. This will be equal to what? Minus 1 all over 4. So we square root both sides of this equation, then that's how we roll. That's how we roll. This will now be x minus 1 is equal to what? With this is going to give you root 1 is 1 times 1. 1 times 1 is a factor square. So root 1 is 1. So this is minus 1. Root 4 is what? Is 2. So this is 2, right? So we have x minus 1 is equal to minus 1. So move this man over to this side. So x is equal to what? Minus 1 all over. Okay, when we start doing this square root both sides, we add our plus minus to that. So if you add your plus minus to this, plus minus to this, so while we are doing this, so this one now, if you transfer this minus 1 to the other side, is going to be positive 1 plus minus what? Plus minus bracket minus 1 all over what? All over 2. Okay, let's do this now. So s is equal to, the first one will be 1 plus. Plus times minus is going to give us a negative sign there. So this will be minus 1 all over what? 2. And if you check that very well, what will that give us? It will give us 1 minus 1 is what? Away. I don't want to get.
The LCM at the right hand side. Let's go back to that LCM. Up, LCM there, the right hand side. That 3 minus 3 plus 4 is supposed to be 1, not minus 1. I think that's where the problem is. Minus 3 plus 4 is supposed to be 1, not minus 1.
Sorry, it's supposed to be 1, not minus 1. Minus 3 plus 4 is the same thing as 4 minus 3. Nothing enter my head. Error. The sleep they follow home here, they follow. Please, let's wake up. Thank you so much for your ego eyes. All the people who are going to count on Nigerian money very soon. So we'll not be hearing that Python or Anaconda or waiting, chop our money, swallow our money. So we are thanking God. We have some ego eyes people here. This is supposed to leave the equation. Imagine that they're taking YouTube video of all this, making mistakes. I beg you. If anybody know start with error, mathematics, if you say you are, so this is supposed to be positive, and then this is 2 all over 2. This is what you're looking for. 1, and then this is x, and this will give you 1 minus 1. You still get the minus. And this is what. Okay. How do we do now? 1 minus 1 is 0. Can x be 0? 1 minus 1, x is 0. Is it possible? Well, I can't tell. But this becomes the root of this particular equation. I hope we get it. Somebody check for us. Is that the answer for this particular one? X is 0, x is 1. There are those people that have the photo, is it photo calculator, the photo math. Is that the answer? I want to be sure. Well, that's all about completing the square. If you try another question, you will get it. Let's move over. Then the quadratic formula. The quadratic formula is something we already. Okay, let's solve the same question using the quadratic formula.
I have seen the answer 1 to 60. Mathematics. The question. I have the question now.
Jesus is Lord.
Oh yeah, drop.
Oh yeah, drop.
Oh yeah, no drop. Oh, because let's summarize it.
1,000 per 1. 1,000 per 1. You hear me? 1,000 per 1.
1,000 per 1.
Hi. 60,000.
Nah, eh.
More than wait to discuss business. I beg. Yes. Wait to discuss business.
1,000 per 1.
Mr. Godspower.
I will pay. Philip. Wait now, I'm talk business, Philip. Mr. James.
Can we go back to that minus 3 plus 4? I think that's where all these mistakes started.
Minus 3 plus 4?
Yes.
minus 3. Change it now. Became a positive 1 all over 4.
Oh, okay. No, I went off.
Okay, change it. Okay, let's
Okay,
take
Mr.
this
Godspower,
example
if
now.
we use
This one.
other means to solve this, won't we arrive at the same answer?
It's the same. We'll get the same.
So why are we killing ourselves with completing the square?
I don't know who sent that message. Mr. James, no dey waste time. Discuss business. Let's solve these things now so that everybody will have the answer. Everybody, are you sure? We have 38 persons. Are
I
you sure
have
we get the 38,000? Mr.
I
James,
have
I'll
the
give you.
code. If I even write your exam, just go to your center, go and do what do you call it? What is that? The register. Like 15. That
Una bad
is coming. So how much you guys
Una
are paying
bad
this one?
oh.
100K?
Mr. James,
5,000.
whining or really?
Mr. James, you
Eh?
are showing yourself.
Eh?
What
100K.
You are showing
This is
yourself.
mathematics.
What are we paying for?
100K.
It was
Mr.
What
James,
is that? What I
kilo leto. Give her go 100k. Kilo shele.
Please, Mr. James, be serious.
100K.
So be serious. If you are serious,
I
we'll
have
take the
the I have the
500.
code. I have the code.
okay.
You just go and
Alright,
press it now.
alright,
Lock
alright.
yourself. Just go
Mr.
to your
James,
center tomorrow and mark your
Mr.
register that
James,
eh?
Not
Computer was
serious.
Mr. James.
English was grammar.
Eh?
Mathematics.
I know that
I'll
anybody
just
that is
joke
But
you
reading
guys.
now,
the people
wait,
will
If you
wait,
like
wait,
actually
I
wait.
know
will
the they will know the time you
Anybody,
wrote the exam now.
so instead, let's just resolve this thing here now, and then
I'll just
question.
joke
So
you. I'll just joke you.
Abi
am I
Mr.
I'll
also
James
just
paying
joke
this
you.
matter?
Tinini. He's a joker.
Oh my
I'll
God,
just joke
Mr.
you.
James,
I'll just joke
You
you.
think he's
I'm
serious?
stop playing. Somebody say
He's
stop
a
playing. Better
joker.
stop playing.
Please, let's move on with our this thing so that we
People
can
body
have
is doing them giri already. You're all on your own.
Yeah,
You are looking for a spoon.
yeah.
The questions gone may not even be the same thing.
Yes, the questions
Eh,
are not the
Everybody,
same for
Some people
everybody.
might have
It's
already
no,
different.
sent me.
yeah, that's what I wanted to do. That I wanted to solve one. So when you see the question, you can be answering.
Please let's go
But
on with our teaching and leave that one.
Mr. James, this is just yes. Somebody sent to
Don't
call
try it
me.
again.
Okay,
Don't do that again.
okay, please speak.
That's the funny
Yeah,
thing for you guys. I'm so glad you did not call me.
sorry.
Eh? You guys did not call me.
Hey,
I
sorry,
just came
Mr.
to
James.
the agency. I
I've
just
been
joined in
asking.
around 11.
I've been calling. Sorry. Madam Rufiat, your background is noisy, and that's why we cannot hear you, Madam Rufiat. A little, just a little. Go ahead, please. You said you're still confused about what? Please, can you just write your question and send it to the chat box, please? Somebody who sees it, please read it for us. Thank you. We can barely hear you, or I believe I'm not the only person, right? Mr. James, help us with your mic. Thank you. Sorry for coming late. Sorry, I have been calling and asking. I don't know why I started that class at Mr. Mohammed, I greet you. I can see that you're also in the class also. And please, whenever you see Rufiat question, please somebody call my attention to. Here we were here. Okay, we've done completing the square, and nobody asked us for completing the square. Okay, let's confirm that answer. That's what we wanted to do. We wanted to confirm this answer using the quadratic formula method. So somebody please memorize this and let's use this other part.
4x squared. Should we?
Okay, go ahead. 4x squared
Minus 8x
-8x
plus 3
plus
is
3
equal
equal
to
to 0.
0.
Okay, now we have always this is in the form of a square plus b square plus c equal to 0. Yeah, this is yeah. So this is
You
correct. This
can
is
see
correct
your
equation.
screen, please.
Seriously, that's an error. Sorry. Uh, so I believe you can see my screen now. You can see my screen now. Everybody can see my screen now, right? I need feedback. Can you see my screen now?
Yes, I
I need.
can.
Okay, fine, fine. So our A here is equal to what? 4, and our B here is equal to what will be our B? Minus 8, and then our C is equal to what? Positive 3. And this is the formula for multiplication. S is equal to minus B plus minus square root B square minus 4AC all over 2A. So this is going to be what is our B? Our B is minus what? Minus 8. So we have our 8 here, plus minus. Then our B is minus 8 square. Then minus 4 times our 1 is what? Our 1 is our A rather. Our A is 4. Multiplied by our C is what? 3. And then this is all over 2 times A, which is what? 4. So with this now, we say this is equal to minus times minus is going to give us positive 8. 8 plus minus, then we have 8 square is going to give us 90.
Your
It
screen
will,
is blank,
90
sir. Am I the only one having the issue?
please. Can everybody
Yeah,
see
No,
my
I
screen?
can actually see the screen.
you're the only one.
Yes, you're the only one.
Okay. Please find me now. Find me. Okay, I've started sharing again so that you can see my screen now, right? The person who was requesting. Can you see my screen now? I need your feedback to move on.
Yes, yes, sir.
Mr.
Okay, so
Godspower, please go up. I want to see the question again. I want to solve it myself.
okay, thank you, madam. There's the previous question that we were solving. 4s squared minus 8s plus 3 equal to 0. So
Okay, thank you.
this now gave us it said 8 times 8 is what? 64. So this is 64. Then minus 4 times 4 is 16. Then 16 times 3 is going to give us what? 32 plus 16 is going to give us 48. Am I right? Somebody check for me before we start making mistake. So minus 64. 64 minus 48 is going to give us what? So this is all over 8. This is going to give us borrow 1 here. 14 minus 8, 8, 9, 10, 11, 12, 13, 14. This is 6. And this is 16. So we have 8 plus minus square root 16 all over 8. And so remember, this is going to give us what? Square root 16. We know square root 16 to be what? This will be 8 plus minus 4. 8 plus minus 4 all over what? 8. So our x is going to be 8 plus 4 all over 8, or 8 minus 4 all over 8. And this is going to give us 8 plus 4 is going to give us 12. Sorry, this is 12 all over 8, or this is 4 all over 8, right? This one, this 2, this is half, and then this is okay. Um, sorry, to go here is to go here is
4. Just go with 4. 4
okay.
there 4. 4 there 3.
For
4 there 2.
Okay, it's the same thing. 4 go here is 2, so 3 over 2. So this is x is equal to 3 all over 2 or 1 all over 2. I think this is where we're making mistake with so the other equations. Did you get anything as half? when we were using that completing the square method. Did you get half?
Yeah. Yes.
Yeah. So how come we did not get the other one? Something was wrong. Something was wrong somewhere.
That one was half and 3/2.
That one also was it 3/2?
Yes, the same thing.
Okay. So we've confirmed that they are the same thing. So we've seen how to use completing the square quadratic formula. Just memorize the quadratic formula. Anything that has to do with all these things, just use quadratic formula. Simple and sure. You will get it. All these things quadratic formula. All this one quadratic formula. Okay, this one now that they said okay, symmetric. You said okay, you sent the question. Sorry, and nobody was observing. Sorry, I made it because everybody should observe. So let's just see question. What's your name again? Gofiat. Gofiat. Uh, am I in the right place? Gofiat, I can't find your question. Okay, it says y is equal to y is equal to 3 times 2 plus 5x plus 10x. Okay, you want us to solve this?
Yes, sir. 3x raised to power 2.
That's not 3x raised to power 2 plus
Yes.
what? 5
Plus 5x
5x.
plus bracket close then x.
Huh?
Yes.
5x, and then we still have all of them is bracket by x.
Yes.
Where did you get this question from? Is it from previous
No, someone sent the
please
question to me as well, so I don't know.
please check if I'm able to call now. Your voice is a little bit clearer than before now, so
Okay.
let's see whether we can now get what we need from you. So call that your this thing again. He said it's root root uh, root what?
Y equals to
Mm-hmm. Y what?
y equals to
Uh-huh.
bracket open
Mm-hmm.
3x raised to power 2
Mm-hmm.
plus 5x
Mm-hmm.
plus x bracket close then x.
Okay.
That's it. Okay, sir.
Y is equal to this is 3x cubed plus 5x squared plus 10x all in square root, square root, square root, square root, square root. So what do you want us to do with this now? Hey, madam. Hey, hey, me don't know what to do. If we pick 10, if we pick x out,
Can you come down a bit? Let me
Or
see
y
the
square. Or we square the
What's the
y so that we can
question?
cancel the square root.
it's the same thing now. Let's say this is root
Will it
3
work to square both sides?
uh, this cannot work because it's plus. This cannot work. I don't know what to do here now. Oh,
How about squaring both sides, sir? Squaring
uh,
both sides.
let's go. Let's square the both sides, as I said. So that this will now be 3s cubed plus 5s squared plus 10x. Sorry, 10x. We are still going to end here. What are we doing? Nothing else. So I don't know where the question is coming from. I don't know what form it's coming, but I don't see
It's
anything
not
to resolve here.
I also think maybe the
5
question is
minus
because I just want to confirm if there
wait,
is
so this is
difference
y,
between.
not in x. The question is not correct, minus correct. Or this will be our final
No,
answer.
it cannot even be the final answer because it's y squared. And y squared cannot be the final answer. It has to be y equal to that square root of 3s cubed plus 5x squared plus 10x. That can be the answer. Or we take a simple term out, then we say this will
Mr.
be
Godspower,
yes.
Shebi, the question is y is equals to square root bracket 3 times 2 plus 5x, then plus 10 bracket close x, isn't it?
He said it was 3
Yes,
raised to power 2. I mean 3x raised to
yes, sir.
power 2.
Okay, see what we do. Why not we
It's
look
3
for
times
the
2. Oh. That is not raised to power 2. Oh. She wrote there. It's 3 times 2, she said. Though.
If she specified, like saying that what she meant to type, I think she,
I
yes.
don't know how to put raised to power two in my typing. That's why I put like that.
okay. So okay, now let me just follow out. Let me just follow this thing the way I'm saying it.
So about here 3 raised to power 2. I get 3 times 3. That is 9. Then
Hmm.
times
It's
2.
not.
So now
Yeah, I didn't.
18.
Yeah, I didn't it like that. We would have gotten an answer. But this one now is something else. Okay, let's look for the. Let's look for the quadratic. This looks like a quadratic equation. So let's just find the factorization of this, the factorized part of this. So what are the two numbers that when you multiply? Okay, first of all, 3 times 10 is going to give us 30. What are those two numbers that when you multiply by themselves, they'll give you 30, and then when you add them, they'll give you 5. That will be 15 times, 15 times, no, 15 will not give you. Um, we should think now. We should think. Two numbers that if you multiply, what are the factors of 30?
6.
5, 3, 10, 6. That's it.
10 times 3 will not even give us 5. We are missing out from here. This is a wrong question. So, my sister, even factorization, move on.
Thank you, sir. It's
What
clear.
is the
Eh?
answer, Madam Muriat? What is the answer for where you get this question?
I've tried it also. I couldn't get the
Because
answer.
if
That's
it
why I
is
put
raised to
power
power
two.
2, you come out with shortcut now, just see y is equals to 3 times 3, which will give you
That's what
9.
my should come out.
3 times 3, which is 9 plus times 2, which is going to give you 18. Then you bring in that 10. You bring in that the 10, it will now turn to is it 28, then plus 5x close the bracket, then x. That is where the solution will end, because you can't do anything after that. I don't know. So that is either the question is not correct, or it is an incomplete question. One of the two.
It's not correct. Even the photo math cannot give a solution.
I ain't doing the photo map. We don't get photo map.
Oh, yeah. Minus, this is
I see the
minus
test, I will
95
keep it with all
all
the
over
math.
6. Okay, so this is not giving us, even quadratic equation is not giving us over minus 95. There's not even a perfect square. So you see that the question is wrong. Once the question is wrong, the answer is wrong. Whoever sent it to you should be careful. Should not send you something that will give you a sleepless night.
Photo, what do
It
you call
does
it,
not exist.
madam?
Someone is saying the radical expression.
Photomat.
Photo
It's a radical expression. Me, I don't see the radical there. I don't see the radical
Check
there.
income message for more details.
Income message. What I leave you. It's thanks, Mr. Okay. Say it's mass. Okay. It's a radical expression. We can only solve for the domain of the. Please speak the English we understand. All these English language people solve for the domain of X. I don't know what you mean by domain of X. All right.
Don't me right time, why?
I understand. Symmetric. Ask the person who wrote it is there. Is listening to symmetric properties of roots and then quadratic equation. So let's take a look at this. They say let the whole of A, let the whole of alpha be B minus. They didn't even say B plus minus. They say B minus 4 B minus root B squared minus 4AC. Then beta should be minus B. And this one is minus B minus. This one is minus B minus. If the two are the same, why are they separating? Then A plus B will be minus A plus B, and then A and B will be C and A. All these things then now waiting now. Let them not bring those all these things. So if alpha and beta are the real roots of equation, 3x squared minus 7x minus 1 is equal to 0. Find A plus B. A plus B is minus B all over A. Then what they call, okay, then A minus B, then find A squared minus B squared, and then find A squared plus B squared. Did they solve it? Let's hear that they solve. They didn't solve it. Equation of reducible to quadratic equation. Why are they behaving like this? They didn't solve that question. Equation of polynomial of degrees greater than 2. All these ones. And therefore their own wahala. If you see all these questions, you can solve them back. Yes. I trust you. The remainder theorem. Remainder theorem. We try to understand this their book like this. Remainder theorem. X plus 1 factor. Example. Continue use syntactic division. Further reading. Now, thank you. The major thing where there's more do, we don't do quadratic equation. The rest of them. Oh, where am I? What's the equation? We're done with polynomials and rational expressions. Have we done this? Have we done polynomials and rational expressions? Have we done that? Am I still connected to the class?
Log reading, please.
Am I still connected?
Yes, sir.
Yes.
Okay, we have done polynomials. Thank you, Michael. All right, so we'll go over to logarithm and exponential functions. Okay. Wow. After that, we go to sequence and series. After sequence and series, we have okay. Then we're almost done now. It then shows complex numbers. We've done complex numbers now. Equations, metrics. Everybody knows metrics, right? No need for metrics. Everybody knows complex numbers, no need for complex numbers, but so what we are doing now is the person who is doing better speak your mind now. Let's reconsider. It's not going to solve
You
the
don't know
matter. Speak
metrics
up.
and complex number. Oh.
Yeah. It's like it's just today some people are joining the class now. Hmm? All this initial
Yes, so some
derivation we
people are
do.
joining for the first time.
Yeah. Logarithm and exponential function. Where did we say we are starting from? This exponential and logarithm functions. Okay. Wow. Talking for 3 hours. I'm going to be solving one or two questions, then I will run and leave them. We'll go and touch every other thing, so that by 12 we can go. Is that okay with us?
Yes.
Okay. We start from this, the function of exponential, blah, 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 exponential growth, exponential function, this into infinity, this, that. This is not what we want to see. Okay, the function, okay, anything that is raised to power 1 is equal to the same number. Anything raised to power 0, we know that to be equal to 1. I believe everybody understand that, right? And I've told you before that, okay, anything raised to power minus that thing, that minus there stands also for 1 all over the power. So it can be 1 all over 2 raised to power 2 raised to power 3. You know, just try to understand that, and they will move. So anytime you see 2 raised to power minus anything, that minus there serves as reciprocal of that particular thing raised to the power or to the exponential of the number that was by the side of the minus. What do I mean? Like 3 raised to power minus 5 is the same thing as 1 all over 3 raised to power 5. So if you understand that those things are exponential functions. So with anything raised to power 0, you know already that is 1. So even if it's 2 million raised to power 0, it's equal to 1. So we also know that anything raised to the power of 1 is equal to itself. So even if it's 3 raised to power 1 is equal to 3. That's what this part is trying to explain. Then the function, we are 3 times 5 raised to power x square minus 2 is an exponential function. Things like this. If you want to solve, then you say 3 times 5 raised to power, okay, 1. Okay, if you do this, 3 times 5 minus 1, okay, given that x is 1, okay, they were saying given that x is 1, if x is 1, as a given exponential, if x is 1, we have 3.5 raised to power 1 raised to power 1 raised to 1 square minus 2, which is the same thing as saying 1 square is the same thing as 1, and 1 minus 2 is minus 1, and 5 minus 1 is the same thing as 5, is the same thing as 1 all over 5 raised to power 1, and 5 raised to power 1 is the same as 5. So the whole of that equation by the left hand side, by the right hand side is 1 all over 5. So if you multiply 3 times 1 all over 5, you're getting 3 over 5. I hope you understand that. Everybody understand that, right? Or do I need to solve that? Everybody get that, right? I need feedback. Did
Yes,
everybody get
yes,
that
we
part?
understand.
Yes, sir.
Fine. So if the second part, they say if x is given as 0, you can see that 3 times 5, 0 raised to power 2 is 0. And so you are left with 5 raised to power minus 2. And it's the same thing as saying 1 all over 5 raised to 5 square, which is 5 square is 25. 3 times 1 all over 25 is the same thing as 3 over 25. The same thing they did for the down part when they say, okay, given that x is equal to what? 2. So if you say 2 raised to power 2, on that 5 raised to power 2 raised to power 2 minus 2. 2 raised to power 2 is 4. So you can see that 4 minus 2 is 2. And then 5 raised to power 2 is 25. 3 times 25 is giving us what 75. So we can we understand laws of exponents. It says suppose this and this and that and that and that and that and that. Say okay, when you're multiplying x times a, you see that the powers are going to be adding together. And when you're dividing, the powers are going to be minusing or subtracting. That's the quotient tool. The other one that has to do with multiplication is follow through. Then power rule, like if you say a times, like a times a raised to power x times another x outside, you are going to say is x times y. So that will not be, if it's a, if it's a raised to power 3 bracket raised to power 4. So you are going to say 3 times 4, which is going to give us 12. So it's going to be a 12. I hope you understand. Now, if we have AB bracket x, so you know also that a is raised to power x and b is the same thing as raised to power x. Then if we have a all over b, all brackets raised to power square, that's the same thing as a square and b square, that is a square divided by b square. We get all this already. I've told you that a raised to power 0 is 1 and a minus x is 1 all over a raised to power x. So is there anything we've not touched or what you don't understand here? These are the whole laws of exponential. Is there anything you don't understand here? Nobody, everybody understands. So the last number is this, and logarithm is that, and then examples. Okay, log 5 raised to power log 5 with 5. Hey, hey. Log 5 with 5. Okay, let's somebody call these questions for us. Let's see a way to solve them together. Are we there? Are we together? Wait, wait. This log 5. It's the same thing as log 5. 5 raised to power 1 over 2. 5 raised to power 1 over 2. If you that's how uncommon logarithms. Sorry, 7 exponential. Yes. Okay, I think this is the main questions we should be looking at. These other ones are just to transfer distance in log 2 8 is the same thing as yeah, log 2 raised to power 2 and all that. Can we solve these questions? Can we solve these particular questions?
Yeah, sure.
We can solve them. Did you say you can solve them? Please give me the answer of the first one. Log 5 raised to power 5.
1 over 2.
1 over 2, right?
Yes, sir.
Then log 2 raised to power 8.
3.
Because it's 2 raised to power what?
2 to power 3.
2 raised to power 3. Alright, then log 6, 1 over 36 is correct.
6
That should,
minus 2.
that should minus 6. That should minus 6.
Huh?
It's 6
That
minus
should,
2.
that should 2. Minus 2 rather.
6 is, it says 6 minus 2.
6 raised to power minus 2, sorry.
So
Correct.
that's minus 2.
Yeah, fine. 6 raised to power minus 2. So this other one, log 2, yeah, log 2 over 3 raised to power 8 over 7,
You
27.
cancel that. You
What will be
cancel
the answer?
that.
That's the last part of it. Over 3, 8 over 27. What will be the answer?
Yes.
So that would,
3.
it will be 3.
Yeah.
Can you explain how it's 3?
It's not that.
Can you explain how it is 3?
Okay, so the 8 normally is that's 2. So we have log 2. So 8 is 2 raised to power 3, While for the 27 is 3 raised to power 3. So normal exponent, then we have 3, which is the same. The what is raised to power is 3, so we just collect the same. Then 2/3 raised to power 3.
So the answer now becomes what?
So the answer is 2/3 raised to power 3, which is 3.
2/3 raised to power 3, which is 3. Why is 2 raised to power 3 raised to power 3? Why is it 3? That's what I want to hear.
No, it's 2/3
2/3
raised to
raised to
power
power
3.
3.
Yes.
Can you solve it? Mm.
Okay, come to the screen now and explain.
Uh, I really can't share my screen, but let me explain. So go back to the question.
Let me use the marker for you so that all of us can. So you tell me what to write, eh? Is that
Okay.
okay?
Yeah.
Fine. All right. We have log 2 all over 3 raised to power 8 all over what? 27. Go ahead.
27.
You said this is 2
So
raised to,
it's
you
the
said
same thing as you can even separate the question into two. So it's the same thing as log 2/8. We solved for that first. Then we will now solve for log 3 raised to power 27. So we'll start with log
I'm
2.
sorry. I think that one is kind of complicated. According to what the teacher wrote, he said you say 2/3 raised to power y is equal to 8/27. So you have to do 2 raised to power 3 and over 3 raised to power 3. So 8/27 is like 2 raised to power 3 over. Then the 27 is 3 raised to power 3 raised to power 3. So equal to 2/3 raised to power 3. So y is equal to 3.
is this what you're saying? So that this and this cancels. That's what I'm saying. If this and this
No, it's
cancels,
not. You don't.
No,
You
let
don't
It
have to
doesn't
cancel
cancel.
like,
cancel.
let
No.
me
You don't have
okay.
to cancel.
He
So what
used
happened?
this
What
what's the
happens
name
here?
of this power? I think you use the power rule this thing in the exponential
Yes,
rule. I
we
use
use the
the
power rule.
power rule.
I think the same
So
So
thing
you
for
because
know that
exponential.
according
Mm,
for this
according
mm,
to
one,
it,
3/3 raised to power 3. I think because they have the same power. So
yes.
that should
So at the
2
end of the day, it's equal to like 2/3 raised to power 3.
raised to power
So y
3.
is equal to 3.
2 raised to power 3. Yes.
Yes.
This
Then
is
y
what
is
you're
equal to
saying.
3. Yes.
So y is equal to
3.
3.
that's why I'm asking why is y equal to 3. So this is
But
how the
no,
answer just goes.
you shouldn't be writing
Eh?
the log from
Uh
Okay.
this
On this
log should
part
not
will
be
not be right.
it should be 2/3 raised to power y.
Why did you people say I'm not
no
supposed to
no 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 no
cancel
no no. You know he
the
said
You
yeah,
assume
the
that
reason
log
why the log left is because it's when it
x, like if you have
goes to
log y equal
exponential.
to x, you have to do how they call it, y is equals to, I don't know how he said it, but at the end of the day that's the answer. I've forgotten the explanation.
this and this has been gotten. This one now is raised to power. So this and this go, then y is standing alone. Y is equal to 3. All this manipulation, I know. Yes,
This thing
yes,
is
yes.
like you saying, "Oh, what will you multiply like with 2? Like how many times will you multiply 2 to give you 8? How many times will you multiply 3 to give you 27?" That's the same thing. So maybe we should just say it that way to make it easier. So you multiply 2
Yes,
3
that was
times.
what he said.
You multiply
Yes.
2 3 times to give you 8. You multiply 3 times to give you 27. So 2 times 2 times 2, 2 times 2 times 2, yes, 8. Then 3 times 3 times 3 is 27.
You know why you get confusing yourself? This thing is
Why?
just simple. We did this thing that day, and we did not. We do not use what they call. We're not using this. If you observe, Mr. Keme, we're not using all these manual. I can't use their
It's
manual.
not our manual,
This
it's
is
the
just
teacher's manual.
supposed to be equal to x. How do you just put something and put equal to empty like that? And then they just keep confusing all of you up and down. I'm even managing. I was surprised to see people are getting the answer. I said, let me be quiet. Oh. You guys are doing well. Oh. You guys are really making us proud. But all you are doing is guess. Some of them are guesswork. Even when you know what you're doing, let's work as professionals a little. But we thank God. Oh, I'm happy that we can still navigate our way through and we get the answer. Some of us are very good at doing crafting. Remember
No,
what
but
we were
this one,
trying to teach
like,
last
I
time? That
watched
this
the
will go
video
like this.
today.
And,
That was what the man said.
uh,
He was the one that solved it
uh,
like that.
all
Yes.
right. So this is now 2 all over 3 x, and then this will be equal to what? And this will be 8 all over
You can't
27.
see your screen,
So
sir.
you can't see my screen like this. Is it the only one?
No, you can
You
see it,
can
but
see.
it's not
You
showing
can
like
see
this
it.
is the position.
But
It's on what?
can you see it now?
It is frozen.
The slide is on what?
Yeah, it's better, right?
Is it better now?
I think that's the best.
Like this is the best. So I said this is supposed to be equal to x, so that you will take the now the x will take the position where the 8 all over 27 was, and then the 8 all over 27 will take the position where the x was. So this is going to be 12 over 3x, then equal to 8 all over 27. So this will now be 12 over 3 is equal to 8. What? How many numbers we go into this is
Two is for 3.
2 raised to power 3. This is 3 raised to power what? 3. So that we can now say this is all over 2 all over 3, the same way we have here. That's what we say 2 all over 3, the same way we have here. So this and this can go now, and then our s is equal to what? 3. You see the way they solve the math? Not all those other ones that you start pushing product through abego. Use the formula that you will not
Different
crash
roads
on the
lead to
road.
the market.
Abi, anyone you can memorize that will give you the shortcut. But I'm surprised that they were able to still get the answers. And I'm just wondering, what's the magic this people play? Because somebody will just see question like equal to what now? That's simple. What's
It's
matter?
not
So
magic.
we can
That's the
solve
way
this now.
the lecturer explained it to.
Abi, it's a prof anyway. I'm just learning. So what do I know? Solving exponential equations. All right. Okay, we can do this also just the same way. Solving exponential. All these ones are things we've done before, so we can do that. This one too. 2 raised to power 2. This is let's solve this. Let's solve this. Somebody give me this question. 8 8 raised to power x minus 8x
8
plus
raised to
2.
power x
Mhm.
plus 2 is equal
Mhm.
to
Mhm.
16 raised to power x plus 1
16 raised to power x plus 1.
plus
So we
1
know that this
is
will be this will be 2 raised to power 2 raised to power 2 times 2 for 4 times 2. This is 3, right? X plus 2, and then this will be 2 raised to power 4, right? Bracket x plus 1. So this and this bro has gone. So it will be 3. Open the bracket. 6 is equal to, open this bracket. So carry this brother here. Carry this sister the other side. So this will be 3x minus 4x is equal to 4 minus 6. And this will give us minus x. And then this one will give us this one will 4 minus 6 is going to give us what? minus
-2.
what? 2. This is divide both sides by minus 1 and minus 1 so that this will go and then s will be positive and this will cancel this so that this will be what? Positive. So we have s is equal to 2. I hope you understand. That is very simple and anybody can solve it. Okay. Move over to the next question. I think we've dwelt so much on this. Let's all these things are just the same. That lean, this particular one, this lean something. Hmm? You can solve this. Nobody's talking. Alright, anyhow, we share. We done. Alright, we are done with logarithmetic. Is there another thing? Exponential and logarithmic function. What is this? Let's say something that relates to what we need to do. If it doesn't relate, we move over.
Mr. Godspower.
Yeah, sir. It's 12. You need to go and sleep, huh?
So, me, I'm going to bed because I have to wake up by 6. My eyes on the
Okay,
deep.
it's something we just.
Eh?
Mr. James, don't try it. That's why I set the class to be early so that you can rest. Because we've been doing this midnight something. Okay, sequence and series. Let me just give you the formula for sequence and series. Mr. James, you've been in class now. You can go and rest. You know all these things. You have these formulas. Hmm? Sequence and series. Can I go?
Go on, go
Yes.
on.
If I say let me give you for the what that man was using there now. If you want to confuse also. Okay, let's go. Let's not fear the man. Let's take his course. I don't like the formula. I use my own. Arithmetic and geometric series. Okay, we have this arithmetic sequence, a sequence for which the difference between any two consecutive terms is a constant. The constant is called common difference. So we know how to get common difference. The common difference is a1. A2 minus a1 will give you common difference. Forget all these other things that they're saying on your own if you don't get it. So if is example one in each of the sequence arithmetic, if so find the common difference. So common difference is 2 minus 1 here will give you common difference, which is what 2 minus 1 is what
1. 1.
common difference of 16 minus 8 will give you what
8.
4 minus 4 minus 4 minus 4 minus 8 minus 4 will give you 4 and then 4 minus 2 will give you so
Stop. Just can you go close to your speaker?
are you not hearing me?
It's faint.
Am I audible enough for every other person?
Yes.
I'm audible enough for every other person. So since I'm writing, I'm
I can
using
hear
my
you
phone.
now.
Okay. Is it more audible now? I just raised the
Yes.
speaker and listen.
Yes, please.
Okay. Um, subtract each term from the subsequent term to determine whether a common difference is. So this other one does not have a common difference. The first one does not have a common difference. Then 4, 9, 14, 19, 24 does not have a common difference. Minus 5, minus 1, 3,
I
5,
think the common difference
11.
is 5.
Common difference is 5.
4, 9, 14. The common difference is 5.
Okay, yeah, that one has a common difference. Thank you. This other one, common difference too, is there. Minus 5 plus
Minus 4. 4.
plus
Plus
4 is going to give us minus 1 plus 4, 3 plus 4, 7 plus 4, 11 plus. So
4.
that other one too also have a common difference of 4, right? Then this one
Yeah.
is 10. 10, 15 all over 2 is 15 all over 2 is
7.5.
hey,
7.5.
is it 7.5? So we have 5.5, 5 over. So what are they adding to this now? Okay, just minus
2.5.
10 all over 2 minus 10. 10 all over 2 minus 10. What will it give you? That is the same thing as saying 20 minus 15. 20 minus, Abi? We said 2, no, we said 15 all over 2
The
minus
common
10.
difference is
That's,
2.5.
are you sure? 15 all
Yeah.
over 2 minus 10. Yeah, 15 minus, it's supposed to be minus 2.5 is not the same thing as
Minus
minus
2.5.
2.5. Am I correct?
Mm.
Fine.
Yes,
So we
minus
understand
2.5.
that part. Minus 2.5. 2.5 is the same thing as saying, when you have like 2.5, let me show us 2.5. 2.5 is the same thing as this. This is 1, this is 2. So it's the same thing as saying 2 times 2 is 4, plus 1, this is 5 all over 2. So it's just like adding 5 all over 2 along every section. So if we add 5 all over 2 plus 5, so 5 all over 2 plus 5, so this will now give you 2, 5 plus 2 times 5 is 10, which is equal to 15 all over 2. That's why you're seeing that other part to be 15 all over 2. You understand? That's why you're seeing 15 all over 2. So that's just how we roll. Terms of an arithmetic progression, first term, this, that. Okay, to write the n term of the use the explicit formula. Okay, to find the n term, you say an is equals to a1, that's initial plus n minus 1 multiplied by the common difference. This is simple. This one will find the nth term, any term. So the difference between two terms is given by an minus ap, which is n minus bd. It's not this particular one. The difference between two terms is that term they gave you plus the one you already know equal to n minus p. Okay, n minus p is the one they gave you plus the one. Well, we'll find this answer somewhere and then we'll solve them. Example 1. Write the first 5 terms of the arithmetic progression that they gave you sequence a with a1 equal to 5 and d equal to 3. What is our a1?
It's equals to minus 3.
Uh,
Equals to minus 3.
I don't understand the equal to minus 3 that you're saying. Put that formula to what we have here.
is 5.
And then how are we going to put it in this answer now? Nobody is getting it.
What are you saying? What are you
Solving
saying?
it, oh.
What are you saying? What are you saying?
The question
I
says
don't get
write the
it.
first. We are solving this, so let's solve it.
First 5
They
term, right?
said, yeah, write the
That's
first 5
5,
terms
right?
of the sequence. Yes, with a1 equal to 5, and then d is equal to what? 3, equal to the an. Okay, no, find the first 5 terms. How do we find the first 5 terms?
Sorry, what I'm seeing here is minus 3. I don't know if I'm the only one.
Yeah,
It's
minus
minus
3.
7. That is the fourth final answer. The
So,
difference
how
is
did you
minus
get
3
there?
now.
Yeah, so how did you get your
Yeah.
minus 7?
N minus 1 is equal to 4. 4 times minus 3 is equal to minus 12 plus the first time, which is 5. Right? That's equal to minus 7. The next which
Wait, tell
fifth
us,
term is minus
calm down
1.
and tell us now. How did you start it?
Our first term
Five.
A1 is equals to 5,
It,
right?
mm-hmm,
Our D
mm-hmm.
is equals to
Then
minus 3. Then we substitute it into the equation which says A1 plus n number of 10, that's minus 1 times D, the difference, the common difference. Then
so what is
A1,
our n?
our n is 5, the first 5 10.
That's our n.
Yeah,
So what is our a1? If
A1
n
is
is
5.
5.
A1 is 5
So
plus,
both n and a1 are 5.
yeah, that's our fifth term. Our fifth term is minus 7. If you want to solve from the second term, then we use A1 plus 2 minus 1 times the common difference, which is minus 3. Then the other
Okay,
one we start
so
with.
okay, now you make me understand. So you are starting
Mhm.
your calculation from the fifth term,
Yeah,
not
yeah, I
the
started it
first
from the
term.
fifth. I didn't start it from the
Because
second term.
because
Our first term is 1. That means 5, rather.
yeah, it's supposed to be a1 plus n, which is 1 minus 1, multiplied by d, and that will give us. Everybody, do you understand this part?
Yes.
Okay. Silent means everybody understands. Thank you so much. Um, the other part, this one they say the difference between two terms. Do we get that part? N minus p. Do you know what is p in the equation?
Is it the difference you are solving from? For?
You said?
Do you want to get difference between the two terms?
Yeah, the two
And the
terms.
first
That
one
would be the second term. What you get in second time minus the first time. That's, do you
The
get, that's
second term,
A2.
minus what?
A2 minus A1 is equals to the common difference.
So
Okay.
most times,
So
most times you're not given A1 and A2. Sometimes you're given like the fifth term and another.
Yeah, you use some of the GP to look for, I mean, some of the AP to look for it.
Yeah.
I didn't get that. Say it again.
Are you talking to me or another person?
Yeah, you said sometimes they are not giving the first term and the last term and the
Last
common
term.
difference. So you do what?
No, they'll give you one. You can't be giving three unknown now.
All right.
You can't be
Okay,
giving three
find
unknown.
the fourth term of arithmetic. Find the fourth term. What will be the fourth term for you? Let's
14th
solve
term.
this one together.
14th term.
Fifth
The
term.
14th term. Let's solve this together so everybody will see. A1 plus bracket 1 minus 1 G. This is the formula, explicit formula. So the 14th term. So the 14th term is what is our 14th term?
So we'll just
Okay.
do
AN.
A14.
Our initial was what?
4.
4. So this is 4 plus
14
14 minus 1.
minus
What
1.
was our common difference? Did we check our common difference? 7 minus 4 will give us what? 3.
It's 3.
So our common difference is 3. So we'll come here and say this is what? 3. So if we do this now, A14 is equal to 4 plus uh, 13, 3. Somebody multiply 13 times 3. What will it give you?
39.
39.
939. So
Sorry.
this is going to be A14
43.
4 plus
43.
39
Just give us like three.
40. So our A1410 of that arithmetic progression was 40, is 43. So the third term of arithmetic sequence is this, is 8 and 16th, and the 16th term is A is 47. Find the eighth term. This one they didn't give us the first term. So what do you think we should do there now?
So I think we should
Use
use this
formula
formula
for the difference
use
of terms.
Difference of terms. We have that as uh, n minus p g, right?
Yes, is equal
So
to a
what is our
n a
okay? A n minus, sorry, I think I've forgotten that.
ap.
Where is it? Where is it? Where is it? A n minus ap
equal to
equals to n minus p g. So what is our a n? Remember they say we should look for, right? Find the eighth term. So our a
So
n will be what?
it's 16th.
Huh?
That is 16th term. So that is 47. 47 minus 8.
Our an is 47. Our ap is 8. 47.
47 minus 8.
Then our n minus p will be what?
16 minus 2.
Minus 8.
3.
Common
So
difference. Did
minus
they give us?
is
No,
8.
that's what we're looking for.
Fine.
no, you're finding the eighth term, not the common difference. But I
You
think you're
find the common difference, then you find the eighth term with the common.
Then
yes,
we now
that
use
was all.
again. Okay.
The P ought to be
So, so 47. Somebody is talking, but we cannot hear you. Is that Mr. Kemen? The voice is very low, I guess. 47 minus 8 is going to give us 39, if I'm not mistaken, right?
yes, sir.
And then this is going to give us 16 minus 3 is going to give us what, 13.
13.
Mm-hmm. If we divide both sides, so this
That's,
going to this is going to give us 3 times, right? Am I
yes, sir.
making mistake? But
No
is it three
mistakes.
times?
Yes.
Yes.
So, so our this is D. So what do we do now to find the eighth term? So we now go to the using our normal formula, right?
Oh, no, we still have to find the first term.
The first term. So we
Yeah.
find the first term
Mm-hmm.
by saying A1 is equal to A1.
No, we take one of the two terms, either the third term or the 16th term. Then we be like A1 plus N minus 1D is equal to whatever term that we choose, like either the 16th or the third, so that we can use that now to find the first term.
So the third term we are using now, is it the 8 or we are using 3?
Whatever you want.
The third term is 8.
Yes.
So we are using 8.
Yes.
This will now be
3 minus 1. Then 3, yes.
2 times 3 is 6. So divide both side by
No, sir, it's not multiplication, it was addition that was between.
okay. Sorry. This is plus. So this is
Sorry, how is that place 3? 3 minus 1. Is it not supposed to be 8 minus 1?
We chose the third term.
It's the third term. The 8 has
third
been
term.
Yeah, the first
8
one is
minus
8.
The third term is 8 now. So, oh, I'm a
8
bit
minus
confused.
1.
Yes,
Like the third term, so like 3.
you're
The
right.
third term is 8.
Okay, so yeah, it's
Term is
supposed
the
to be.
term.
Like what number
Third
of
term.
term? Is it 3?
Okay.
21. 21 over 3. So if we transfer this one to, it's going to be since it's plus, since it's plus, are we still following?
Sir,
21
you are not meant to change it to 8. It was still 3.
say 3.
Yes, you are not meant to switch them up. It's still 8 that's there and 3 that's on the right hand side.
An is equal to a1 plus bracket n minus 1 d, and we choose
Hmm?
the third term to be a1 then plus the
No,
third term the n.
No,
no,
like
no, 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 no.
Why?
AN is
Wait,
A
let him finish.
we're
and
First.
using
N
Let
is
him
A.
finish. Let him
3.
learn first.
We're using A3. So that A3 is going to 8 because A3 is our third term.
Okay,
Yes.
So
a1. That's what I was correcting from the other side. So minus 1 all over 3 that we got
exactly.
as the difference. This is
Which
what I was
yeah,
correcting from the other one. So this is supposed to be 8 is equal to a1, then we have 2 times 3. This is going to give us a1 plus what? 6.
Plus 6. Yeah.
A1 is equal to 8 minus 6, which is
So
a1 is equal to 2. So we've gotten our a1 to be 2. So we
now we
say
can find the
a
eighth.
n equals to a1 plus n minus 1 g. Here we have the what term did they say we should find now?
8.
The
8 10. 8 10.
find the eighth term. So we go over here. Our a8 is equal to initial 2 plus n is 8 minus 1 all over d. So eighth term is equal to 2 plus this is 7 all over 3, and this is a8 is equal to 2 plus 21, and then this is equal to a8 is equal to what? 20, 23. So the 3 is the answer to that question. Do you understand that now? Mm. Well, thank you so much. Solving example, this and that, sequence and series, this and that. Example, that geometric progression. Do we know the formula for geometric progression? Hmm?
8 times r is per a minus 1.
Yeah, to find the We are supposed to sleep by now. I'm sorry. I just want to see where we can cover up to. So find the common ratio. Common ratio is D2 all over D1. This will give you a common ratio. And then the other one is A dot what?
8 times.
Who can remember?
Which one?
Huh?
Do the sum.
The to get the end stem.
Yeah, that is 8 times r raised to n minus 1.
R raised to power minus one. N minus one or minus one.
N minus 1. N minus 1.
N minus one. Then all over the down part will be what?
There is no down part. That is for the sum. Oh. The sum that has down part. The
Okay,
for the
some that
first.
has down part.
Yes, sir.
This one is A dot arrow N minus one.
Yes, sir.
I'm not consulting my book now, so even me, I want to hold it in my heart. So the sum is A dot. Are they going to ask us to do sum? I don't think so. Let's just hold this to heart anyway. These are the formulas that are necessary to go into that exam hall with. Sequence and series, we're done with that one. Okay, what was that circular trigonometric ratio? We finished that. Complex numbers. We did complex numbers last time. Let's explain it again. Did they say polynomials is coming out? Did they give any concentration on polynomials? Hmm?
Yes, it's part of it.
If you see polynomial running, polynomial is simple anyway. But we've done it just that it will take a little bit time. Okay, this one imaginary number. Imaginary number is root minus one. Root minus one, which is that I. So root minus one times root minus one is root minus one times that's minus one times minus one, which is going to give us what? It's going to give us minus one because the root is going to be minus one root minus one square, which is going to give us minus one. Then if you say minus one times minus one, it's going to give us one. And that will be I raised to power four. And that's what they were just doing here. Not here. When they ask you I raised to power four is what? Just what is I raised to power three? I raised to power three will be minus one
Minus 1.
multiplied by
And
root minus one. So that's just it. You understand? This is minus 5 plus 4i, then plus 3 minus. All these things we can solve them, they're not difficult. It's normal simplification that we normally do already. So complex numbers. Example, complex conjugate. Okay, where we were adding that rational number. When we are dealing with rational number, this is how we did this other part too. Dividing complex numbers. It's similar. So like look at this example now. Let's say minus 5 plus 4i, then 3 minus 2i. It's just to say minus 5 plus 4i, then multiply by the conjugate is to change that 3 plus, that 3 minus, change it to 3 plus. And when you multiply all of them, they give us this number at the top and then the one at the down. Remember that the one at the down, one must cancel one out. So it will now give us 13. So you can see that 2i, that 2i there, like 4i and 2i, if you multiply them, when you expatiate this thing, you are going to have 8i squared and 8i. You know that I is, let me not even talk about the I, but we know that I square is 1. So that 8 times I square is the same thing as 8 times 1. So it's going to be 8. So you carry that 8 now, go to where 15 is. And that's why we are having minus, that's why we are having minus 23 there. There's something I'm missing. Minus 10i plus 12i is going to give us 2i. Then that minus that 8, that minus 8. We say I square I raised to power 4 is 1, but I square is minus 1. So that minus 1 is what made that 8 to become minus. Do you remember? Because I say I believe you know. Hope we all remember.
Yes, sir.
Okay, fine. So that's what made that one to be like that. So we now have minus 23 all over 2i, which is all over 13. Check. This question came out for our mid semester, at the end of semester, which is minus 23 all over this and that and that. So this is just the answer. Now we can solve complex numbers. That's what I think here is just story for the ghost. We move over to metrics, right? Introduction. Okay, go over to metrics. What have we not done on metrics? We said to find metrics. Do I even need to explain all this part again?
Please explain. Please explain,
Yes.
sir.
Multiplication of the inverse of the matrix. It's just to get a multiplied by. I think inverse of the matrix is half a. We'll get that.
The inverse of a matrix is 1 over the determinant times the adjoint.
Yeah, 1 over determinant. That's 1 over a j what so 1 over determinant multiplied by the aij adjoint of a, the adjoint of matrix A. So we look for a short form of getting those things last time. So determinant of a matrix order 2. Okay, when dealing with determinant, let's just look for example and get determinant. Determinant is just multiply the first term and the second term. You see that cross multiply there. They do another cross multiply and then you get the answer. That this minus 5 all over 2. I mean this minus 5 and 4 on the same row and column. Column is to the right hand side, row is to the right hand side, column is from up to down. So we have minus 5 and 4 on the first column and 7 and 2 on the second column. And then if we want to get determinant, it's just to say 5 multiplied by 2, that's the cross multiply. Then you say 4 multiplied by 7. And if we do that, it's going to give us minus 38. So minus 38 becomes the determinant of that particular expression. This is for 2 by 2 matrix. If you check 3 by 3 matrix, there's another pattern towards it. You have to pick a like this one now. There's a find determinant of 3 by 3 matrix. You see now you pick 2, then you blind everything on the row and the column of that 2. Then you multiply minus 2 times 5. Then by 3 and multiply from 3 and minus 1. I'm getting tired. This minus this, the top one minus the down one. So if you check, what I'm trying to say here is this is going to be a. You pick two, like you pick only the first row, and then you do what you need to do there. Somebody give me this. Let me solve also so that you will understand what I'm trying. Can somebody pick this for us? Everybody understand how to get determinant? Does everybody understand how to get determinant?
No, no, no.
No, no, sir. No, sir.
Please, please give me this. Give me this matrix. Give me this matrix. Let me solve it so I can. I'm
Just so
coming.
you can leave it together.
Um, excuse me. If you check this now, you pick two. Two is the top one. They say minus two times five. That's one side, and then that will be minus two times five minus two times five minus.
We cannot see the other screen. No.
I'm coming,
We can't
please.
see your board, Mr. Gospel.
Yeah. When there's a mistake, you use their formula, they use your.
Okay. I'm coming. All right. Please call this number to me.
So on the first row, 2, 1, and 0. On the second row, you have 1 minus 2 and minus 1. And on the 1 minus 2 and minus 1. And the third row, there is 1, 3, 5.
Okay. So when you pick uh, when you pick these two, you blind everybody here. So we are going to have minus two times five minus okay 3 times minus one. So, mhm. And we are going to follow the convention of here will be plus, here will be minus, and here will be plus. So by that now, we say minus 2 times this is going to give us 10. 10 minus times minus is going to give us plus. 3 times 1 is going to give us, is
That
going
should
to
be
give
minus
us what?
1.
Minus
That should
1, yes.
minus times that should be minus 10.
Minus 10, correct, yeah, correct. So this will be plus 3, so which is equal to what? This is minus
Minus 7.
7. This is for the first this thing. We do the second line. The second line is
That is minus times 1 times 5.
Sorry, Mr. Gospel. I want to ask something. Can I answer?
yes, you can ask.
Mr. Gospel,
Yes, you can ask.
I'm sorry, please. I want to clarify. How did you come about minus 2 times 5? Please, don't be offended. That first line, can you explain, please?
Alright. We've been doing this thing over and over in our previous classes, so I was just thinking everybody understand.
Yeah, I know. I've actually not done any. I've actually
Sorry,
not
so
done any matrix class. Please.
to find the determinant of A, you have to say you pick the two. So two will be bracket. Then you cover everything on the roll. So we are not going to see everything on this row and the row and the column of where two is. So we are going to pick this against this and this against that. You understand? So if you do like that, so this will now be equal to two brackets minus 2 times 5. Are you getting where we got minus 2 times 5 now? Minus 2 times 5 will now be minus 10 minus. Then 3 times minus 1 is going to give 1 minus 3. Minus 3 minus 3. Minus 3 times minus is going to go up plus 3. So this is how we managed to get this one to be what? This one now became minus 7. So we hold it down. If you want to complete it, this will be minus 14. Let's just finish this part. Now, this top side we enjoy the convention of positive. This one we enjoy negative, and this one we enjoy positive. That's how we run it. Yeah. So the second part will be minus what's the second element there? That's
Minus
1. Then
Your
one.
first answer is
Okay.
supposed to be -7, not 14, not -14.
times 2.
Yeah, you remember times 2 now. The two that you pick outside. Remember now. Remember that.
Okay, I'm multiplying by 2.
Yeah, these two outside here.
Okay.
Remember. So now we pick our 1. Remember the sign at the top is minus. So if we blind everything around here and everything around here, what we are saying is 1 and 5. So it's going to be 1 against 5 by multiplication and this against this. I hope you understand. So with that now, it's going to be 1 times 5 is what? 5 minus 1 times minus 1 is going to be what? Minus 1. Minus 1. Then minus times minus 1 is going to be plus 1. So if we do that, it's going to give us 6. Then minus 1 times 6 is still going to give us minus what? 6. Okay, so we go for the third term, which is almost the last one, is 0. Now we know that anything multiplied by 0, so anything we get here is going to give us 0. This is going to give us 0. Do you know why? Because, okay, now if we blind everything here, we're having 1 times 3 and 1 times minus 2. So it's going to give 1 times 3 is 3, minus 1 times minus 2 is minus 2 times minus is going to be plus 2. So this is supposed to give us 5. 5 times 0 is the same thing as 0. So by the time we add our cardinality, what they call, sorry, our determinant, this is going to give us minus
Minus
14 minus 6, which is equal to what?
minus 20.
Which is equal to minus 20. So this becomes our determinant. You understand? Minus 20. So you can see here that we have minus
Yes,
20
sir. Thank you.
as our determinant. Thank you. So um, getting the adjoint, I don't know how we do that. Properties of determinant, this and that. Adjoint of a matrix is this. Adjoint of a matrix is just to change the matrix, that to get the that we did for determinant to do for every element. That's an adjoint.
Then
Then to get
no,
the
that's
inverse of the
cofactor now.
matrix.
That's cofactor.
Yeah, that's cofactor. It's not,
Adjoint is
yeah,
changing row to
yeah,
column.
cofactor. Yeah. When you change all the cofactors to be
The
transpose
transpose.
of the cofactors, it will give you the adjoint of that matrix. So it's almost the same thing. So A inverse says adjoint A all over determinant. So you can see 1 all over determinant multiplied by adjoint A. I will say adjoint A is just the B transpose. And B transpose, the B matrix B is just getting the cofactors of all the matrix A, just as we've clearly stated. That thing we did for determinant. You have to do it for all of the elements for you to get the cofactors. But there is a shortcut to which we used last time. I would also like us to look at that shortcut before we close. The shortcut, we said, okay, they say find the inverse of A. Find the inverse of A. Somebody give me this. Somebody give me this, please. Somebody give me that. The first row is what?
231.
231. Second row,
331.
331.
331. Third row,
241.
241. So how do we find our matrix now? Our determinant. Because first they say we should find the A inverse. So A inverse is equal to adjoint of A all over what? A determinant. Adjoint A, adjoint A all over determinant. So let's find what is our determinant first. What is our determinant? At the time we put our plus sign here, minus and plus here. We have our two first, two brackets. If you blind the row and column of two, you have 3 times 1 is 3. 3 minus 4, or 4 times 1. 3 minus 4 is going to give us what? Minus 1, right? So this is going to give us 2 times this minus 2. And the second one we have 3 minus 3 bracket open. That will cover the rows and column. We have 3 times 1 is going to give us 3. Then 3 minus 2 times 1 is 2. 3 minus 2 is going to give us 1. If we multiply minus 3 times 1 is going to give us minus 3. Then we check the last term there, which is 1, positive 1. And then we close the column and the row. We have 3 times 4 is 12. Then 4 is 12. Then 2 times 3 is 6. Then 12 minus 6 is going to give us 6. If you multiply that by 1, we're getting 6. So we say our determinant is minus 2 minus 3 plus 6. Minus 2 minus 3 is equal to what? Minus 5 plus 6 is equal, that's 6 minus 5. So our determinant is equal to what? 1. Are you saying? So we have a determinant as 1. So now we go over to this other part. To find an A inverse, this is what we do. This is the trick. This is what we do. A inverse. So we write our first our first um, matrix element 231. Then we have 331, and then we have 241. Are we following? So now we have to add the first. We add the first two. These first two columns on the right hand side. So it's going to be 2, 3, 1, 2, 3, 1, 2, 3, 1. No, the second one is going to be 2, 3, 1, and then 3, 3, 1. I guess. Excuse me, I need to confirm this. Okay, we are supposed to repeat the first two columns as they are on the row side. So it's going to be minus 2. So this is
I cannot see you. I'm seeing something
yeah.
different on your screen. Or better.
Everyone, good night. Or
Thank you.
want to go and rest.
Yeah, thank you.
Okay.
One by one like that. Oh, go. Thank you. Now this is the part I was trying to search. Okay, we are supposed to get. We're supposed to get this other one. We repeat the row and column on this other side. It's supposed to be 1. Sorry, it's supposed to be 2,
2, 3,
3,
3,
2.
3, 2, 4.
So this one will now will repeat the first and second column. So this will now be 3,
3, 3,
3,
4.
4. So now we'll now repeat this one. These two now we'll repeat it under. It will now be it will now be 2, 3, 1, 2, 2, 3, 1, 2.
3. 2, 3, 1, 2, 3.
1, 2, 3. And then this one will be 3, 3, 1, 3, 3. So we'll blind this and then we'll blind this. I just hope you are correct in what 1 minus 1, 0 and 1. So I'm supposed to take 2, 3, 2. Okay, all right. Okay, yeah, we are correct. No, I haven't done this now. We do what they call um we do this as this as this as this. So if we do that together, it's going to be 3 times that is going to give us a use that one to form a and we want it to be equal to B transpose. Instead of putting it like this, putting it like this. So and B transpose is the same thing as adjoint of A. Adjoint of adjoint of A. So let's go. 3 times 1 is what? Is 3. 3 4 times 1 is 4. So if you minus that, it's going to be 3 minus 4, which is going to give us minus 1 here. Then we'll do the second one. 4 times 1 is 4 minus 3 times 1, which is 4 minus 3, which is 1. Remember, I'm supposed to put it down, but I'm putting it to the right hand side, which is the transpose part of it. Then we have 3 times 1 is 3 minus 3 times 1. So we have 0 there. So the second part we have 1 times 2 is 2 minus 2 minus 3 is going to give us minus 1. Then the other part is 1 times 2 is 2. 1 2 so 2 minus 2 is 0. Then 1 times 3 is 3. 3 minus 2 is going to give us 1. So the last part is 3 times 4. 3 times 4 is 12. 2 times 3 is 6. So 12 minus 6 is going to give
6.
us
6.
6. Then 2 times 3 is 6. 2 times 8, 2 times 4 is 8. 6 minus 8 is going to give us minus
Minus
2. So this other one, 2 times 3 is 6. Then
9.
6 minus 9 is going to give us minus 3. So we use this now. So we come back here now that A inverse, come back here, and then we see our A inverse is equal to the determinant. What was the determinant? Our A inverse is 1 all over determinant bracket of minus 1, 1, 0, minus 1, 0, 1, 6, minus 2, minus 3, all the way. So this becomes our answer. Let's check. Minus 1, 1, 0, minus 1, 0, 1, 6, minus 2, minus 3. Was it the same thing we got? Yeah, 6 minus 2 minus 3. Are you seeing? all
Yes,
over
sir.
the earth. So they know that since it is one all over one is the same thing as one, right? So and we know that one times the whole of this thing is the same thing as that number there. You understand? So that's why you cannot find this particular one here. They just remove it and this becomes the answer. Do you understand?
Yes, sir.
So that has finished. We've finished everything about metrics. We've done complex numbers and that's all. Thank you so much. I want to see you with successes in your exams. We pray that God grant us the the success that we desire. Thank you so much. We've taken 4 hours, 4 hours on this, and I'm happy that we were able to stay. I'm looking for okay. So how many persons do we still have still with us? If you are awake, say I'm awake. Oh. Is it Temitope? You have your hands raised. 31 people left. All right. Thank you so much, everybody. Mr. Mohammed, you're still with us. Thank you so much. I'll see all of you. Madam Blessing, Joshua, Blessing Oka, Chino Jerem, Ikuma Ibe, Emmanuel, Khadijat, Kingsley, Munu Chisom, okay, Manu Chisom, then Michelle, Mojisola, a great woman, uh, Ogene Rueme, I cannot see any completely, I greet you.
Well
Oluwademi,
done.
then
Well done. I
I greet
appreciate you.
you. Philip,